See if the live stream's working. It is. It's not really updating, is it? Start stream. That might be my badge. Okay.
Veggie sliders and both meat sliders. So it's snacks. So.
I think so.
I saw the sliders came out.
rare one. I don't have many of those. I only have 2 more. Should have gotten the Mac, man. I'm telling you. You can run Docker build on that? I'm kidding. No C volume issues or whatever. Yeah.
I mean, I have worked in Kubernetes, but
You shouldn't. If everything goes well, you'll never have to run it locally. So that's what the power of the cloud. You'll see even today. Nothing is. It's all in the browser. So there's browser using a shell, but yeah.
are you using Google Kubernetes right now, or?
Mhm.
Or really, we do?
Yeah. I ain't gonna run that. I ain't gonna run Kubernetes. Crazy.
Because, like, you know, all the things we work with still in AWS.
No. Google.
That's why I don't know anything that we do with AWS.
It's not much. It's not much. It's not much different. I mean, the hardest leap you guys already took was the container. Once you have the container, it's just a matter of where you run it. Right now, it's just the fact that I have some tooling to run your Kubernetes, or sorry, your container. But with Kubernetes, it's just built to do that, right? You know, if you want to scale, you don't have to talk to me. You just like look at Kubernetes docs and do it.
Yeah.
Right. So, in other words, we're lazy and we don't want to have to. We don't have to develop. Yeah.
I mean, my concern is Lambda functions, actually.
They have cloud functions. Wait, what do you mean Lambda functions?
Because I feel like, you know, like, Lambda functions we created is a lot more AWS specific than, like, Docker.
What's AWS specific about them? I guess.
Like CloudWatch,
Sure.
all this IAM policies, like S3s we use.
Yeah, but there's just different. It means there's equivalent services in GCP if you need to do it. I mean, worst case, if you really need it, you could talk cross cloud, right?
Yeah, so it has to be public network, I guess.
It already is. Most of the S3 is already public endpoint.
But since all of our servers on fucking private network, right? I mean,
Sure.
it's the one we use. I'm not sure about others.
Yeah, I mean, all in all, it's like if there's a reason to do it, do it. If not, I mean, whatever. I mean, the nice thing about Google is too, they also have something called Cloud Run. And Cloud Run, it was announced last past year. And Cloud Run is essentially, it can take any container and run it for you as like a managed serverless platform. So with Lambda, you have to play by Lambda rules, right? You have to say like, oh, well, no, you're missing a handler. Oh, no, you're missing, VPC permissions.
Yeah.
With Cloud Run, it's a little bit more flexible. It's, hey, here's a .NET Core container and run it. Okay, as long as you serve up HTTP, you're good.
Oh, so there's no like API gateway.
It's literally, you give it a container, it'll scale it for you and everything. And then on top of that, the cooler one of that is you can actually run Cloud Run on GKE. So you can deploy your Cloud Run and run it inside of a cluster you already have.
Okay.
And then when you start talking that, then your mind can run wild. Service discovery comes to mind, right?
Yeah.
You don't have to do DNS records, you can just look it up in this deal. So, we'll see. But there is equivalent, there's like Cloud Functions. That's their Lambda. Cloud Functions is their Lambda.
Lambda function.
You saw the food outside, right? If you wanted some food.
Yeah, I'm just not hungry yet, so.
Okay. You might as well just get a plate and leave it next to you. So if you do get hungry while you're working, you don't have to get away.
Check it out. Then.
Yeah, exactly. Hello. Think so.
When's the last time you did this one?
March 2018. Was it? Yeah,
Yeah,
GoGo.
something like
It was at GoGo. And we had
Yeah.
200 something people. That was crazy.
Wait, did we have that event, or was that you doing it just for?
It was GCP. Or is it our event?
Yeah, I remember that one.
Yeah.
That one was packed. Like the
Yeah.
entire room was packed and all.
Well, it's convenient because the location's right by the train.
We like ran out of outlets, and we had to bring extra.
And we ran out of
tables.
I remember we ran out of food.
We had to bring the tables in.
Yeah, luckily we ordered food, remember? Because if
Yeah.
not, then there wasn't
I
enough.
remember that.
Yeah.
That one was chaotic. This one will be good.
Yeah, it's fine. We'll see. Small crowd, big crowd. At live stream.
Yeah, is that working? All right.
And have a chat too.
Sweet. I'm gonna put it out on our Twitter thing.
Mm-hmm.
Okay, yeah. So there's join the live stream. All right.
See if it works for you. Curious.
Yeah.
Audio probably won't work for music, but it should work for.
That was real fast. Looks good.
Nice.
I'll stay on here throughout the event and see if anybody has questions.
Yeah, that'd be good. Like I'm sure
Yeah.
people are like, "Hey, what is that?"
I know.
Yeah.
I'm also working, so.
Yeah.
If you see me on the computer, that's what I'm doing.
I like this kind of. This is my music to work actually.
This is.
Chill wait, whatever. Did it actually come through?
Yeah, I'm trying to hear what that was.
Oh, I think it was me talking and it's picking up the talk.
So it's working. Great.
While we're waiting, we'll probably start here in maybe 10, 15 minutes, but if you don't have a Quick Labs account, you can go ahead and just register ahead of time. The website is quicklabs.com. If you do have an account, you can sign out because that'll make things easier. But if you don't have an account, go to quicklabs.com. Just create an account. That's the most boring part of the whole day. You know, give an email, password, and make sure you get your confirmation and everything. So just create an account if you don't already have one. If you do have one, just log out, and we'll pick up from here. We'll do a whole slew of announcements and stuff. The Wi-Fi is Google Guest, if anyone's curious. Yeah. Sorry, that was on the first slide.
Quick question.
What's up?
I previously done another quick lab session, so I still have that account. Does that still
Use whatever account you want the 1 month credit to be applied to. Yeah. So everyone here will get a 1 month. So if you don't finish the lab, there's no pressure. You can go home. You can do more labs if you want. And in fact, sorry? Google Guest. There's no Google Guest at all. Interesting. Maybe they call it Google Guest like can you try that? If you put the airplane mode on, is the disabled the network? You scan the network. If you click on network and internet settings, Windows Wi-Fi? Oh yeah, that's it. Much nicer to be here. So you yeah. Let's try it. Let's see.
I mean, okay.
Alright, some internet. I'm not sure if it's cool to add. I'm actually never know that. Okay, I'll make it. If you can't see Google Guest, it may be Google Guest Legacy. So, yeah, seating is all open, pop sockets and stuff. Hey, how's it going? I've never seen you before. Welcome to our Meetup. You were the first one to print.
Really?
Yeah.
My name wasn't there.
It was Mike Russell. It was Mike.
I know.
That's
Well,
all.
I didn't see it on the table. They're like, oh, take it upstairs, so things are printing out. And they're like, oh, we can't because it's already printed. And they're like trying to figure out how to print. I'm like, what? Michael, that's your name.
I saw it. Maybe I took it and still don't talk about it. How's your Google Cloud Chicago? Get Shake Shack out of it?
Yeah,
So
No.
No?
it's like kind of.
Well, that's it.
No, I went there by myself.
Oh.
Sorry. What are you here for? I'm like an interview. Because she's, I keep saying she's like, I'll put you in the phone.
Serious?
Huh?
Serious? Serious? Or are you kidding?
No.
Really?
Wait, what?
You.
I'm here for this.
Okay, I was gonna say.
Because she keeps telling me she's like, doesn't work out. She's her front one.
God help whoever gets you the
Right?
Oh my gosh, that's so stupid. Bad David. That's actually pretty good. You should take some back.
I am.
There's a ton of them if you want to take some to your team.
Actually, I'm, two of my employees are supposed to come today, but
Cool. If they can't, well, there's a live stream too.
I know I already sent
Sent
it.
it them? Cool.
Yeah, actually, I got not nasty grabs, but like, I wish I would have known about this sooner. I'm like, well, I can't have the whole office with this thing.
Yeah, so
It was to all our developers though.
who cares? Let them join. Yeah, tell them live stream if they want to watch and listen to me talk. I'm gonna supplement it with material too, so it's not just gonna be me clicking and copying and paste. I don't know if it'll work out. We'll see.
I have this rain.
Oh, you never had it? You want some?
No.
Look at the can.
Oh, it kind of looked like.
It's Monster's secondary brand to make it a stronger energy drink.
Oh, Jesus Christ, 300 milligrams.
Yeah, so it's like a Bang, but it's a rain. So I think we should be live streaming as well.
Yeah, I sent a link there.
Cool. So in the spirit of community, if you know people that maybe couldn't have made it, there's also a live stream as well. We're streaming this as well to people. So if you know a friend who was like really wanted to come but couldn't find a babysitter or couldn't get off work and whatever, please blast this out. We're happy to share. And let me put it on the Meetup page, and then that way you just say to the folks to go to Meetup.
My buddy Joel.
Hey.
He's running it, so.
What up?
One of
Good.
their co-runners. So it's just doing introduction.
Cool.
Yeah, Daniel.
Hey, how's it
Good
going?
to meet
You work together? Or like,
Yeah.
Cool. Developer on the same team?
DevOps.
Cool. Awesome. Welcome.
So he's the one at Red Rocks that also with the soft serve for the
Oh, okay, got it. I've now heard of you, just didn't know name. Yeah.
Yeah. It's a feedback loop. How about that? Let's just say.
Thank you for putting this on.
No worries. Hey, it's for the community. So, hey, all. Cool. I put it in the Meetup website, so if anyone has friends, the Meetup sent the message out. So it's gonna be live stream, and then at the end of it, I think YouTube turns it into a video recording, so you can go back to it as well.
What do you think, 12:15, 12:20 or
Yeah, 12:15. I was
Yeah.
thinking just
Okay.
because I have my slew of announcements as a team. We're just gonna say like, hey,
Gotcha.
next event,
So
next
you have
event.
a trailer.
Yeah.
All
Sneak
the trailer,
peek.
the trailer reel, basically.
Yeah.
I showed for the pictures from the last one.
Yeah, I have an album somewhere. So we'll be getting started here in probably 2 to 3 minutes. Again, coffee, water in the bags. We're expecting still sliders outside. Get food. You'll get to sell some food. We're going to be doing a lot of typing and coding, so bring it back. If you haven't already signed up, there's our website called Quick Labs. That's where we're going to be using to facilitate today's experience. We're going to also have some content as well. It's not just going to be running through a lab and we're going to actually talk about it and stuff. So if you have an account, just hit sign out. It'll be great because then we'll all start on the same platform. There's not going to be a question of I'm signed in and I can't do this, and I'm signed out and I can't do that. So just if you have an account, sign out. If you don't have an account, just register. It takes about 2 to 3 minutes. So. Okay, cool. I love it. Let's do it.
I'm sorry. Come over. Yeah.
Yeah, and I left you.
Yes, I know.
After 3 months of that startup.
You were Yes.
Yeah, now you know. He knows the drama.
No wonder. Yeah, I still don't like
Yeah. It's easier to support tomatoes than like kiwi.
Yes, all the way to the back.
Yeah. Yeah. Well, that water's really good. That's like a lemon. Yeah, no, they had a whole slide theme thing of bobber. The best thing is like the slides are literally just this morning at like 2 in the morning last night. I'm like, yeah, I should have something.
I know, I downloaded it just in case. I was like, I can't walk into the event and see it.
I'm hoping the code works. That's my thing.
One of it will work.
Well, no, it's just one code that they said like it's
Oh, for
only
the-
available between this window and this window, and I'm like 12 o'clock Chicago time, not like California or New York time.
Between what is it?
And they said their code will activate at 11:30.
And
It'll go to the. I can't because I'm not so you can try it. It's
It's in the slides.
yeah. So like literally when it says like enter a code, just type it in there. Basically, go through the slides and you should be able to.
But I have to make a quick lab thing, right?
Yeah. Did you sign up for it or no?
I have before. I'm sure it's gonna work.
Yeah, I'm sure it'll be fine. Yeah.
I liked your picture. Yeah, that's cute.
The sword. That's what one of my friends was like. Because speaking of circus, I was like, everyone else is like, nice shirt, and it's just you like, ah. I'm like, go for broke.
I think my picture is like weird.
Gotta have fun with it. Be who you want to be. Right? So that's the phrase that they say. Like,
It's
be
who I am. It's easier to be who I am.
Exactly.
Somebody else. Is this what? He's out there talking. You're sitting by the food.
Yeah, he should be coming in. In fact, what I'm gonna do. He was following me. Maybe he got lost.
He started talking.
There he is. Yeah, no, no, no.
Yeah, it makes it like an
Just like, what am I was just thinking, like, maybe I could sit and type, but no. Cool. All right. So it's 12, 18, so we have a lot of stuff to cover, a lot of material, so let's just get started. Basically, thanks to our sponsors for our usual meetups. They're great. They sponsor our DevFest. Without them, we wouldn't have been able to do our DevFest. Check them out. Really great companies. SSID is there. I'm also told that if you do not see Google Guest, it may be Google Guest Legacy. So if you don't see an internet connection, check that out. Maybe that's what you need to connect to. But I've seen both. Yeah, it's weird. So either Google Guest or Google Guest Legacy should connect you to your internet today. Follow us on Twitter. We're not that weird, and we'd like to blast out things like this every now and then, saying upcoming events, promote other events in Chicago, like Kotlin, Flutter, various other events throughout the city. And if you aren't on our meetup page, I'm curious how you found us today, but please sign up. We're a great community. We have 5,000 strong, and we're happy for everyone in the community.
And growing.
And growing.
Speaking of Meetup.
Yeah. Do you want to take a sip?
Yeah, sure. So, I don't know if any of you guys heard, Meetup decided they like to make profits now, apparently. Yeah. So, don't worry about it. From our perspective, we don't plan on charging you, because that's bullshit. The community should learn and find, it'll be fine.
Yep.
We're in the pro network, so we don't get charged. You guys don't get charged. It works out for everyone.
Yep.
So yeah, we're good. If anything changes, I think it's still going to be free somehow. We'll make it work.
Yep.
Because I want this community to be awesome. So. Yeah.
Oh, Women Tech Makers. Hi, I'm Dina. I'm a co-organizer here, but I'm also the Chicago ambassador for Women Tech Makers, which is a program through Google to provide visibility, community, and resources for women in technology. What I want to underscore is that it's free to join. You just go to that website. What you're going to find right away when you join up is they have a lot of curated resources for people in different levels of their career. So if you're just starting out in development, or if maybe you're already established in technology, they have different types of resources. They also have downloadable workshops that you can take, like for topics like unconscious bias, that you can use in your own workplace. In addition, they have a mentorship program where they will unite you with ambassadors all across the globe, and other little things like they have a yearly dinner like right before Google I/O for all the women tech makers. So here in Chicago, as part of this, I organized the quarterly spotlight on women tech makers. I have events in Chicago. If you're interested in speaking or volunteering, or if you know somebody who is, please come find me. You can also contact me through the Meetup site. Again, my name's Dina, and I look forward to meeting more of you.
Woohoo! Yay. Yeah, great community overall. It's awesome. Every year we're growing, and so looking for more events. In the theme of growing community, we're also looking at, we understand that part of our community is also cloud, is also developer, and sometimes it's like, hey, there's just not enough cloud events, or hey, there's too many developer events. How can we meet this kind of medium? So we're actually in the process of working to establish GDG Cloud Chicago, focused purely on cloud events for the cloud professionals out there. So that's gonna be great. So more to follow soon, but just so you know, probably maybe next event we'll have some more details to share with that. Upcoming November 13th, we have an event here again at Google. It's gonna be on the 6th floor though. Site reliability engineering at Google. It's not at Google, but it's at Google, like in the
Location.
In the location, yeah. If you are interested, please sign up. Again, it's on our Meetup page, and I don't expect people to know how to type this. It actually fits pretty well on the screen here. But go to our Meetup page. It's there. It's going to be a great event, great evening. We have a speaker flying in, Jose Andrade from California, to speak on SRE. It's going to be great.
We're gonna do a holiday
It's
party.
gonna happen. We just don't know when or where.
Yeah.
It's happening.
But point is, not every event should be learn. Let's have some social, get some awesome networking,
Yep.
Yeah.
have a good time.
And meet other community groups in
And-
Chicago. That's
Yeah.
I think it's actually frowned upon to do like a holiday announcement in October. You know, like isn't it like you're supposed
No,
to let Halloween
no,
go?
No, you need to announce the party.
Okay,
ahead of time.
fine.
December,
So
December.
sometime in December, more details to follow, but it'll be great. Just come, turn your brains off, and we've worked hard all year, so let's just have fun together. Cool. And that being said, it is time to start our study jam. High flying. Today we
You're
are going to
much
be doing
smarter on that
a
stuff.
intro level things Dina, things Dan. We're going to be doing our intro into Kubernetes and a little bit more. So where we're at Google. So hopefully you all found the building right. You're all in seats, so it's great. If you're joining from the live stream, thank you for joining us. We're happy to have you, whether you're in person or remote. It's great. A little bit about myself, just to kind of get details out of the way. I'm Joel Vassallo. I'm manager of Cloud DevOps at Redbox. My Twitter's there if you want to yell at me after this and say, you said everything wrong about Kubernetes. Go ahead. I don't care. I can take it. GDG Chicago co-organizer as well. So great community and looking to keep growing. So thank you all. Before we start, some ground rules. Look, this is a collaborative environment. Just be excellent to one another. There's maybe some Kubernetes masters here who know everything, and maybe there's people who've never even seen Docker. We're all here to learn. If you see someone struggling, help one another out, right? Just be nice to one another. And again, with that being said, help each other out. Again, we're all here to learn. We're gonna have a few people kind of circling the room. If you have questions, raise your hand. We rather address and teach than just kind of watch me mindless copy commands, right? If you have a question on things that we're covering, maybe I don't even know the answer, but we'll all learn together, right? So that's kind of the goal here. And I also have some content to supplement the labs, because I do know some of the feedback I get, at least myself, when I run quick labs is, it's great, but it just feels like I'm copying and pasting what you're telling me to do. I actually not absorbing any of this stuff. So I'm gonna kind of try and supplement that. Maybe it'll work, maybe it won't. Maybe give me feedback at the end of it if it was good or not. So, the agenda is actually pretty good on time. We're doing pretty well. We're just welcoming you guys here. 12:15, we're going to get started on getting access to Quick Labs. A few of you have already saw either creating accounts or already have accounts. Awesome. We have 4 labs on track today. The 4 labs are kind of covering from the bare basics, intro to Docker. Docker is not necessarily a core Kubernetes topic, but it's very important to understand in the context of Kubernetes, right? Lab number 2, we're also gonna have a break because I don't know about y'all, but just sitting in front of a computer and typing is great, but your brain could just turn into mush. So we'll take a quick 15-minute break, go to the bathroom, get some water, get some coffee, get some snacks, relax, talk with one another, whatever. Lab number 2 is a little bit more practical. It's about actually creating a Kubernetes cluster. It's actually going into a cloud console, creating a cluster using Google Cloud, right? And lab number 3 is kind of taking that a step forward and actually doing something with that cluster. Again, one is very infrastructure focused about creating a cluster, and the other one is very, all right, we have a cluster, now what? Again, we'll do another break because we need some time. And the last one is kind of actually doing some deployments, right? Hey, we have a cluster, we kind of understand what we're doing here. Let's make a website and let's see how this loads. And let's make a change to that website and see it seamlessly fail over between one change and another change, right? And then just wrap up the evening, just maybe some announcements. I will say for the folks who do successfully complete the lab, there is an incentive to do so. So stick around till it's the end. So please, that'd be great. Cool. So with that being said, let's get started. Step 1, go to quicklabs.com. If you have an account, sign out. If you don't have an account, create an account now. So you get an option to either sign with Google, probably the easiest, at least for me, or whatever. But either create an account and sign out, and we'll go from there. So I'll give maybe folks maybe a minute or two there, and we'll do a show of hands if anyone's still stuck. How many? Oh, go ahead.
I don't see a signing with Google.
Yeah.
By the way.
Yeah, you can use that if you want, either one.
No, I don't see it.
It isn't there. Yeah.
Canaries, alpha, it's great. Look at it. No, I don't know. Maybe you decided to not do it. Really?
Yeah.
I like that.
I click join here.
I don't know. Well, I guess there's no sign in with Google, but my slides in between yesterday and today, I guess, may have changed. So sorry, I saw a sign in with Google. Maybe some of you do see it. Maybe it's like an A/B test, right? Like maybe half this room, you know. No, it's gonna be great. So you could do sign up with email in that case. How many folks have used kind of Quick Labs before? In a show of hands. Okay, good, nice, that's good. Yeah, it's a great platform. The best part of it is you don't have to use your cache to kind of create your clusters and stuff, right? You just kind of get in, learn, click, and follow the commands, right? Do a check here in a minute or so just to see. Is anyone like kind of stuck even creating an account? That's a bigger thing. Like they don't know, they don't even see the website. Awesome, no hands is great on that. That's awesome. All right, so who is like doesn't have an account? We're still waiting. I just want to make sure. Cool, awesome. So step 2, go to this link, and I realize this. I should have probably blasted this somewhere. I'll actually put this in the meetup too, but it's go.quicklabs.com/cloud-study-jams 2019. Hopefully, can everyone see that, or do you need me to make that bigger? Anyone in the room? Good, cool. And when you load that, hit the enroll Kubernetes in the Google Cloud button. You should see it's like the second one in the row. Again, me yesterday. Kubernetes in the Google Cloud. In fact, I shall. Did anyone get stuck? Yep. Yeah, we'll get to that. That's step 3. So if you got there, we'll just hang out. You'll see like, hey, what's the access code? You're probably like, come on, give me the details. Let's go. But just do a check here in a minute. Is anyone stuck right now? Like I just wanted again, this is the most critical and probably the most boring part of the whole evening. Okay, what's up? Oh, you're still hoping you're still good. No one is anyone still like not working. Oh, you're just to, well, I think everyone may have this. I'm going to go ahead and post this on the Meetup page. Once you have an account, go to What did I say people to click? Sorry, I'm just doing this for the folks in the live stream. If folks see bad quality on the live stream, sometimes you have to turn up the quality on YouTube. I think it defaults to like 480p. So for the folks on the live stream, I think I saw a comment saying it's a little blurry. Sometimes you can make it 720. I'm broadcasting at 1080p as well. So just a little cogwheel and increase the quality. Cool. And then if also you need to like type these links, you can't see it on the screen for whatever reason, I'm also putting them in the Meetup comments as well. So if you get to go back or whatever. So with that, step 3, this is the access code for the evening. It is 1S Chicago 0924. This is the moment of truth to see if all the hard work and registration actually works. It doesn't work. Then we got lied to. No, we'll figure it out if it does. So hopefully this will grant everyone in the room here and also the folks on the live stream 1 month of training. So if you want to supplement this with other quick labs, you have full access to the catalog for a whole month. So whether you want to do Kubernetes, you want to look at BigQuery, machine learning, whatever, there's a ton of quick labs out there. What's up?
When does it start?
When you sign up, okay, so that's a great question. Make sure you sign up today. The code is time sensitive. If you're not following along today or on the live stream and you're watching this, maybe tonight, make sure that you sign up today. The code is only accessible for today only. And then it'll start from today for a month, so October.
How was the day? Is that like at midnight?
Oh, when's the deadline to end? Probably midnight, yeah. Yeah. And then we'll touch on it too, but if you complete the lab successfully, you should get a second month as well. So you'll have 2 months. So sometime in December, you'll get 2 months of training.
So when we complete the 4 labs before midnight?
Correct. Not before, as long as you complete them in the first month of you having the credits, you'll get another month added to your account.
Oh, okay.
Yeah, so you don't have to rush to this. Again, the point of this is to learn. If you need to go back and go through this again, please, by all means, do so. As long as you complete it within the first month, you'll also get another month added to your account. Is anyone having issues entering this in? Any errors? Because we also have folks at Quick Labs who could help us out. Hopefully, people have successfully brought this in and it's working. It's like a success. Yeah, cool, awesome. I love when things work. This was not fun when I first did this about a year ago. It did not work for like half the room, and we were just running around, and yeah. So, sorry. I'm going to also share this on Meetup. Again, sorry for the small text. So I will also put this on meetup.com. Important. Register today using the code. Cool. So for the sake of time, I'm assuming no one's stuck. People are logged in. They typed in the code. And folks on the live stream, again, Meetup comments as well. And the slides will also be shared after, so don't worry, too. Step 4, sign in with your account. So just make sure that the account that you use to sign up today is what you're signed in with on the platform. So I guess right now, sign in, make sure that you're logged in, and you see your quest. So for me, I guess this is where I have to actually get started. Roll. Cool. So hopefully we should all see this. It says about 5 hours. There's a lot of content to read. We'll make the most of the time. I do want to let folks know that one of the labs is unfortunately offline. It's the last one. It's called Continuous Delivery with Jenkins. However, I will supplement that with some material as well as something you can do on your own time to get the kind of same benefit of that as well. Offline, sometimes the labs go offline for maintenance in the sense that they're tooling it. Some commands may not work. People say the lab doesn't work, right? Instead of having a bunch of frustrated people as to why things aren't working, let's go back and let's fix it, and we'll do that. So right now it's unfortunately offline, but I will supplement it with some material, so maybe you kind of get some of that out of today as well. But still, there's plenty of content, so no shortage of content. So I'll do a check here maybe in a minute or so. Is anyone having issues getting this far? There's a pillar in my way, so. Cool.
You should say in the front, once you sign in introduction to Docker.
Yes.
Yes.
Excuse me. Would you mind just turning around? Yeah, what's up?
I get here, right? And then just go back to the back to sign.
Did you sign in?
I did.
And okay. And if you
And I signed out and I recreated it. Bring me back.
the sneak around in the back. How about just let's log in. Cool. See your icon now. If you hit enroll in this one. Skip this video. So cool. You should be good. Let me know. However, let me know if you see anything because there's a little bit of a weird flow. Yeah, so I'll keep an eye on it. All right. For the sake of time, has anyone kind of like catastrophically lost help? I don't have an account, so nothing's working. Just want to make sure, again, this is the most important part. As this is just boring, so. Cool, I don't see anyone yelling or running out the door, so let's get started. So the first lab that we're going to be doing today is an introduction to Docker. And before starting this, just show of hands, how many people know what Docker is? Like, and these are people, okay, it's a good side of the room. How many people have heard of it but never really used it or just here to learn more about it? Good. No, that's awesome. It's going to be great. It's going to cover everything. So this lab, there's a few things to get started, but I always like to supplement my content with, let me get this here. I'll present. So lab 1, Intro to Docker. I always like to supplement it with a little bit of a history background as to like what are containers, why are containers here, and a little bit of history to it. So I did this presentation a few months ago, and it was actually pretty helpful for some folks. So if folks hopefully find some value in this here too. So if you've never heard of Docker or VMs or anything, you're probably in the room now like VMs versus containers. Wait, what's Kubernetes? How did we get here? Right? It's 2019. Like, how did software development and infrastructure get to this state of the world? So if we kind of take a step all the way back to the beginning, we had the concept of bare metal. Bare metal being a piece of, you could very much consider it like a desktop that had a hard drive, it could run one OS, and it had your apps on there, right? You could put 3 apps on there, it'll be great. It's pretty easy to set up. You have dedicated hardware. However, if there was an unexpected failure, a power supply fails, your network card no longer works, you're kind of having to rush for this. And it's also very expensive in the land of IT. Like, I mean, at least for me, I have a desktop at home. I don't have another one just lying around, right? I have to go buy parts, and that could take hours. If it happens at midnight, I have to wait till the morning. If I'm running critical infrastructure, you have to have that on hand, right? There's still an important case for this today in the world of computing. However, solving for hardware failure, the world kind of moved to this concept of virtual machines. In the room, infrastructure folks, anyone familiar with the concept of virtual machines? VMs? Cool. So basically what the VMs are, on top of bare metal, you segment to multiple operating systems, right? You have virtualized machines, hence the name. This is great. You can now have shared compute. You can have multiple apps running. You can have a Windows box here. You can have a Linux box here, all running on one piece of hardware. If a VM dies, it could be bad, but it's not as bad as like the entire system going down, right? A bad patch gets installed. Hey, you know what? Create a new VM, move on. However, still, this caused some issues with constraints of scaling, right? I don't have any more hard drive space to allocate to my VMs. I don't have any more network space to handle. I'm basically at capacity. Well, what do you have to do? We have to go back, provision more servers on another system, and do the same thing over again. VMs are great, though. Again, still critical to infrastructure today. So weather update, the clouds. This is kind of the advent of the cloud landscape as to why cloud became this popular term and why we have it today. Again, some of the advantages, if I need a VM, I just hit run VM. I don't have to worry about compute. That's Google's problem. I don't have to worry about, is this enough throughput? I just pay someone else to worry about it. That being said, you have to pay for it. So something to keep in mind. There's API driven, so if you're a developer and you want to write software against these clouds, it's great. There's a lot of interfaces, software as a service, a lot of built into these platforms. With that being said, you lose visibility. You no longer know whether that light is really blinking green or if it's red. Did the port go bad? Sometimes the VM just disappears because termination or instance reboot, right? You're still limited by OS boot times as well. Operating system boot times, again, just for the simple terms of when I go home and I hit start on my computer, I have to wait for Windows to start. I have to load up all my startup programs, and then I'm good to go. I don't know if I also necessarily want to do that. It could take about 2-3 minutes, 4 minutes on older machines, right? And trust in cloud providers, right? Again, it's kind of going back to the circle of, do I trust so-and-so with my data? Do I trust it to be here? Do I trust them to maintain redundancy of that as well? But it's still here today, and it's quite popular. So somewhere in that phase, this term of immutable infrastructure came up. And immutable infrastructure came of the mentality of cattle, not pets. So you name your cats. You don't necessarily give cows names, right? You name your cat Fluffy, you name your dog Rex, but you don't just have them as commodity. So what this mentality is very much like this GIF here. Basically, in the old world, you would have an instance, you would log in, SSH in, copy some files on, restart the process, you're good to go. That VM probably lives in the data center or in the cloud even for months, years, whatever. With the immutable infrastructure is spin up a new copy of it, move traffic to the new one, and destroy the old one. Just get rid of it. I don't need it anymore. If I have to roll back, just boot up the image, destroy the one I just rolled out, and I'm back into this. You're no longer talking around the OS as a limiting factor. You're talking about it as more of a commodity. Hey, I just need a VM. I need Linux. I need Windows. I need something. Best part of this, it makes rollouts a little bit easier. So, as you can kind of see with this image of how to patch. But we still have a problem, and I alluded to this earlier, around booting of the OS. When doing software delivery, sometimes you have to wait for the operating system to boot. If you're doing critical patches, like a Windows patch or a Linux kernel patch, you have to wait for the box to restart, start up, then load up your .NET, your Java, whatever it may be. And the advent of container runtimes kind of became popular. So what a container is essentially another layer of virtualization. This is probably not the right term for it, but it's the easiest way to explain it. On top of the operating system, now you can run multiple containers on one operating system, right? So no longer are you worrying about every time I deploy, I have to change my operating system. You're just adding another container. So if you want Nginx, you want a Tomcat, you want a .NET, it's very segmented pieces of your operating system, right? The best part of it is these containers are very small. I don't know about y'all, but Windows is a very large thing to install. It could be gigs, right? Linux, gigs as well. It's a lot of overhead. Containers are very focused as to what you are running. So if you're running Nginx, like a web server, you're just running the web server. That's all you really care about. You're running Tomcat, all you worry about is Tomcat, which is probably a few megabytes, right? So containers are very small and boot up very fast. And to kind of supplement that, they're declarative in nature. And we'll see that today in action. Some of the cons, again, if you don't have space on your virtual machine to run the container, you're still going to be supplemented to the same issues today. I don't have any more RAM to allocate to this container I'm trying to boot. I can't do 5 Nginx servers, I can only do 4. I try to run the 4th one out of memory. No more storage, unable to provision network capacity. Right, so you still have that. On top of it too, I don't know about y'all, but when I was getting started, it's a lot of confusion. So you're telling me, okay, I have hardware, which has a virtual machine, okay, I got that. Now you're saying there's a virtualized process in that VM. So how do I log in? How do I check the logs? It's all of a sudden moved to this kind of layer of, in reality, a little bit of layer of introspection that you kind of have to understand. It's relatively new in the computing space, right? So it's something to kind of learn and grasp. And that's why we're here today. But with that being said, since you can segment your containers and basically ship them around, the concept of it worked locally kind of goes out the door, right? If it worked on my laptop, aside from a few things, maybe some wrong configuration flags, it's gonna work on another server, right? As long as I follow the same prescribed process I did locally, I should be able to put it there. So in short, that's kind of what I like to sum it up as. So with that being said, let's actually get started. Let's actually start typing some keys and actually doing some of this stuff. So if we go to the introduction for Docker, so again, Docker is, I'm going to read it out. Docker is an open source platform for developing, shipping, and running your applications. With Docker, you can separate your applications from your infrastructure and treat your infrastructure like a managed application. Docker will help you ship your code faster, test it faster, deploy it faster, and shorten the cycle between writing code and running your code faster. I don't know, I guess they must have just said extra faster in there. Docker does this by combining kernel optimizations with workflows and tooling that can help you manage and deploy your applications. We kind of briefly skimmed over that. There's a lot to take into that statement. But for now, just take it for what it is. When you use it, you'll kind of see a little bit more of it. Docker containers can be used directly within Kubernetes, which allow you to run in Kubernetes engine with ease. And after learning the essentials of Docker, you'll have the skill sets to start. So what are we going to learn here today? We're going to learn how to build, run, and debug a container. We're going to learn how to pull a container image down from Docker Hub and the Google Container Registry. And we're also going to learn how to push containers out to the world. This is an introductory lab. Just to preface with this is very, I'm sure a lot of folks in the room may know all this. Again, if you see someone that doesn't understand what we're typing, please help out. Again, community. So to get started, at the top right, there's a button called Start Lab. Hit that button, and you'll have like launch your subscription, I believe. I'm the instructor, so I have a little bit of a different UI than you guys. But hopefully y'all have like launch your subscription on the side here. Does anyone not see that? No? Anyone? 1, 2. Cool.
Use subscription.
Use subscription, yes. It's use subscription, something that is on the left side. Is it good? Cool. Does anyone not see that and they're getting scary warnings? What's up?
Is it in Kubernetes in Google Cloud?
Yeah, so if you scroll down, it's intro to Docker. And you hit lab. Can you go back to the
Yeah. I actually reduced the time before you got started.
Yeah, I did.
And then I went to that link.
It should still be fine. So go to what do you I did the code here earlier. Yeah, I did. Let me share that again. It sounds like there's quite a bit of people stuck on here. So again, go to Quick Labs if you have already. You got to go to Quick Labs Study Jams and click on enroll in this Kubernetes in the Google Cloud. We're there. Is anyone not here yet? Okay. This is the code to use where it'll say Study Jam access code. Enter this code on the page there. Does anyone see this? Or did anyone not see this? Is anyone still? This is also on the Meetup page as well. I posted it as a comment, so if you can't read it, it's also there as well. S.
When you guys end up there,
Chicago at dash. Chicago.
All lowercase,
All
right?
lowercase, yeah. Dash 09
9,
24.
2, 4. This is lower.
Case. Yep.
All right. Don't say I've never helped you out.
Yeah.
So what's the answer to the internet access to?
Use subscription. Yeah. So you got the credit. So when you get to the page of Intro to Docker and hit Start, you should see Use Subscription if everything clicked right. If you don't see that, please, we'll be walking around helping. Is anyone stuck that I could help out? Okay.
Carlos, do we have to have them in this classroom? Do they have to use the same email address that they signed up for?
Yes.
Oh, because we have
Yeah,
the
we have
code?
the code, yeah.
So if somebody has
And then this code,
and then you come back out. Then you got the subscription.
Anyone else stuck? Everyone's still good? You go on to the next one? Okay. Yeah, no, we'll get to it. Right now, people weren't even getting credits. Yeah, we'll switch to it, yeah. Good? Okay. Folks will be going around the room if you haven't been able to hit the start button, but we will hit the start button at the top and use subscription if everything went well. You'll see this button, open the Google console. So this is where it gets a little confusing. When you click on here, you're going to usually probably see something like this if you're like me. I have multiple Gmail accounts, right? So you have to click use another account. It's all the way at the bottom.
or incognito mode.
Or incognito mode as well, yeah. So that's actually a pro tip. If you, yeah, pro tip, if you don't want to get signed out of your Google Chrome and all these crazy emails and stuff, you can open up another incognito window and just copy this link. Here. So you'll be prompted to sign in. What you need to do is take the username. Everyone has a different username, so it's not the same as me. Don't sign in as me, because again, I'll get kicked out. So everyone has, if everyone's successful, they'll see use your credentials here. So hit next. We'll copy the password. And you'll hit next. If everything goes well, you'll see like this giant terms and service, which is lovely. It's a brand new account. It says temporary provision for the purposes of this lab. All you do is you hit accept. You'll see this a lot. Just hit done, because this is a temporary account. You don't have to worry about recovering your password or anything. You'll see this every time you do a quick lab. Just hit done. So when you load up, you'll see this as well. Country, United States, that's where we're doing the lab. And I agree to terms and service. There's a lot of terms and service we have to agree for our labs today. But if everything went well, you'll see a Google Cloud Console. And I want to stop here. Folks, good here? Have they gotten this far? Anyone stuck, lost? There's a pillar in my way. Cool. What's up? Yes. So if you go back to the quick lab section, don't close this window. Go back to the one of those. You see, there's a username and password that gets provisioned every time you quick lab. Use that.
Yeah, because it's weird.
You can do it here or use your incognito window. Yeah, do that too. Okay, next. Yep. Cool. Hit the accept and done. You don't have to enter any of your personal information. Just hit done, next. Yeah.
Thank you.
No worries. Cool. For the sake of time, I'm gonna progress. I think majority of folks, is anyone like severely stuck? Okay, you'll see this Google Cloud Console loaded up. Something to note, one of our attendees mentioned that sometimes you don't see the Quick Labs project. So within the console, there is a project selector at the top of the page here. Make sure that you see the Quick Labs project that's on your account. There should only be one if everything is going well. There should only be one project if everything is good. So for me, Quick Labs are great because there's material and things to supplement it. So what I typically do is I split the screen left and right, and I kind of follow along. I suggest most folks do the same because, again, you're going to be flipping back and forth quite a bit. So on one side, put your content, on the other side, get there. So we actually just did this Quick Labs setup. We hit the Start Lab. We got our credentials. You hit Use Another Account. You sign in. And we actually got here. So if everyone sees this, we're going to, for the most of our labs today, we're going to be leveraging the Google Cloud Shell. The Google Cloud Shell is essentially a small, lightweight Linux shell in your browser. That way you don't have to worry about installing anything on your laptops or complexities of that. It kind of simplifies a lot of that to get started. So to activate the Cloud Shell, it's actually relatively simple. At the top of the page, there's a Activate Cloud Shell next to this little speech bubble. It's Activate Cloud Shell. So you're going to click that. You're going to see a pop-up on the bottom, fly over, and it's going to say Cloud Shell. So you hit Continue. So if everyone's Cloud Shell is working, you should hopefully see something similar to what you see on my screen. You'll see like a black terminal shell. If you've never used a terminal before and you're not very comfortable with it, don't worry. It's going to be minimal. We'll walk through. We'll explain everything we're typing and why we're typing it, more importantly. So I just want to do a quick time check to make sure folks are progressing along. Is anyone stuck with the shell part right now? Okay. Cool. So we walked through activating the Cloud Shell. If everything worked well, in fact, let me see if I can make this a little bit bigger. I can. Make this a little bit smaller here. Much nicer. It's the mastery of putting your windows together. So the first command that we're going to run is gcloud off list. So if you don't like typing like I do, when you highlight over these little text boxes, sometimes you'll see this little copy icon. It just makes it awesome because all you have to do is copy and paste. So gcloud is the command line interface to interface with Google Cloud and your projects and various things and resources within the Cloud Console. You can use the GUI. The GUI is great. It's easy to see and visualize. But sometimes after a certain time of doing it once is great. Doing it 2 times it gets a little annoying. Doing it 50 times you're like, I am tired of checking the box yes every time, and I just want to hit the enter button 50 times or write a shell script or a Python script. That's where Google Cloud Console, gcloud, comes into play. What gcloud auth list does is it lists your credentials that you have installed, if you will, to your Google Cloud Console. So if everything went well, you'll see student and some weird numbers. So hopefully everyone sees that. You can also, again, just to confirm you're in the right project, do gcloud config list project. And what this does is it actually outputs the project and that the Quick Lab set up. It also should match the project that we said earlier at the top of the page. So mine is 7562. If I look here, 7562. Again, just kind of giving you the familiarity of the Google Cloud Shell. This thing can do a lot of things from provisioning clusters to even getting credentials, and we'll see some of that as well. So, actually doing Docker. We're no longer, we're actually going to get the ball rolling on what is Docker, how to run it. So the beautiful thing about Google Cloud Shell is it already comes with Docker pre-installed. You don't have to worry about going to some website, hitting run, and worrying about permission issues and firewalls and whatever. The Cloud Shell has you covered. So you hit this Docker run hello world. Basically what we are saying is Docker, the program, run the image hello world. This is the most simplest example of getting started with Docker. But a lot occurs in this process.
That's right, unless you wanted to
So, if everything worked well, you kind of see this hello from Docker, and a bunch of this message appears to be this installation appears to be working correctly. So that means that Docker is working. You were able to use an image. You were able to run a container. A lot happened here, even though it doesn't seem like much from one command. So I said that we ran and pulled a successful image. An image is essentially a snapshot, if you will, of a Docker, essentially a Docker process that was installed and created. To see this, if you run the command docker images, you'll see that your shell has successfully downloaded a hello world image of the tag latest, and we'll touch on that in a little bit. The image ID is a hash. Hashes are very important in the context of Docker. That's how they use to describe different layers and different versions, if you will, to know there may be multiple versions of the same image, right? As a software developer, we may have version 1, version 2, version 3, version 4. We can't just have them all mushed together, right? We want to be very specific and say, I want to deploy version 2 today, and next week I'll deploy version 3. hashes are very important to denote the differences. In this case, the latest tag has a hash of this FC28 stuff. It was created 9 months ago. That's helpful. We're humans. We like to know when things were made, right? And also, more importantly, the size. I was able to run this, and I think everyone here, in a matter of seconds because it was only 1 kilobyte. It's like the image on a website. It's how small a container can really be. Again, this container probably isn't the most exciting, but it is doing quite a bit. So we kind of get this here. This image was actually sourced from Docker Hub. So if we look here, this says this image was pulled from Docker Hub, which is a public registry, and the image ID is provided in a SHA-256 format. This field specifies a Docker image that has been provisioned. When the Docker daemon can't find the image locally, it will search a public registry to find that image. So I don't have a program called Hello World. I didn't write any code. I showed you guys my terminal. I didn't sneak any commands into my terminal. So where did Hello World actually come from? So the beautiful thing about Docker is there's a concept of a public registry. And what a public registry is there's a bunch of you in the room, and maybe you all have contributions to give. You can upload your created images to a thing called Docker Hub, a public registry, and just share your runtime, right? So in here, I should be able to type hello world and see that we have an image here that's available. And this is actually what was pulled down. We didn't do this command, but this is the actual image available out in the world. So someone was out there, wrote a hello world. We just pull it down and run it locally, which is great. Again, the concept of sharing your content.
So is the template actually copied locally and then it's instantiated from there?
Correct. So there's an image that gets uploaded up to this Docker Hub, a public registry. When you do Docker run, it'll say, do I have hello world locally? I do not. So let me go check if Docker Hub has it, or GCR. There could be many registries out there. It doesn't just have to be Docker Hub. In this case, it is Docker Hub. Let's just see. Is there an image up there? There is. Let me download that down so I don't have to get that again. So in fact, there's actually a command later in the lab that will show that. But for now, if we do the command docker ps, Docker PS is like Docker process. There's nothing running. So what happened here? Like we obviously saw hello world. Where is it? Like what happened? Like did I just paste that into a shell? No. It's very important to understand that Docker will run a process until it terminates. So it will do Docker run hello world. There's nothing else related to it. It just starts up and shuts down. Something has to keep it running, right? In the context of software development, this is where things like Tomcat, things like Jetty, things like .NET, things like Nginx, things that will always be running, listening for incoming requests. But if it's just printing hello world, like everyone has their favorite programming language or bash scripting, all it's going to do is print, shut down. So that's why we don't see everything. However, in triaging this, we may want to know what happened here. So there is a command, docker ps-a, which will show there was a successful container that ran. It ran the command /hello. Again, I don't know what that's doing. That's what the person wrote the software. It was created 5 minutes ago, and it exited 0. 0 is good. Anything else is 0 is usually some error along the way. So that means that it ran 5 minutes ago on my machine, and then it just stopped because that's probably what was expected. The beauty of Docker is you don't have to pull the image again. And what I mean by that is if we look at my initial output, we actually can kind of see quite a bit. Unable to find the image hello world latest locally. Latest is pulling from the library hello world. The pull is complete. It digested. It makes sure that there wasn't any corruption in downloading that the signature matches what was pulled. And it runs it. If I run this again, the docker run hello world command, you won't see any of that. because it's already available locally. I don't have to go ahead and download it again. I'm not downloading a kilobyte. That 1 kilobyte container or image is already on my Cloud Shell here. So you can run this as many times as you want, and it just gets faster because it's just, again, run before. Again, to supplement that, if I do Docker PS, nothing's running, nothing's listening. But if I do Docker PS-A, there's all those lovely commands that ran because I said hello once, 6 minutes ago, 31 seconds ago, 16 seconds ago. Something started, something ran, it exited successfully. Right? So that's kind of like the basics of what a container is. Like, again, there's an image that gets pulled down, it runs that image and listens until it's done. It's done doing work. In this case, the hello world. It just printed hello world, it was done, we're clean, that's why it exited 0. So you're probably wondering, that's great, well, how do I actually build a container? How do I make a container so I can actually write my code and do stuff that's fun, right? So that's where the command, we'll actually do this here together. We'll need to make a folder so we can kind of keep our files together, right? So this command here, make dir test and cd test, all it's saying is, for the folks who are not familiar with command line, is make a directory, make dir test, and essentially, and cd, change directory test. So you copy this. Again, I love this feature of just copy and pasting because I hate typos and I stink at typing, especially in live demos. If everything went well, you should see like a tilde/test here. Again, if you're not familiar with the command line, it's fine, but you just basically create a directory, like a folder, very much like on Windows, where you create a folder system and you drop your files, very same. And CD is your opening, double-clicking it, going into it. This is where it's going to be very important that we hit this copy button. Hit the copy button on create a Docker file down here, and I'll actually explain what is going on here. It's a little bit verbose, and this is one of the things that I don't like about the platform, because it's kind of like you're just copying and pasting. You don't really know what's actually happening here. So when you copy that and you paste it into your terminal and you hit enter, you're probably wondering what the heck just happened. Did I just create a Docker image? Did I take down the internet? I don't know. All that made was a file called a Docker file. So basically what it's saying, and again, this is a little bit on command line syntax. It's saying cat, like essentially take all the input and put it into this file called Docker file. So you'll see somewhere, actually get a better habit of this, cat everything into a file called Docker file. EOF is end of file. So essentially is copy these lines. Let me see if I can highlight how that looks. Hopefully it doesn't look bad. And put it into a Docker file. Again, this isn't so much Docker related at all. It's all shell, but I do know that folks in the room may have never had shell experience or used shell in a day-to-day. So I'm covering it a little bit slowly. So if we break this down, what is this doing? What is this Docker file? A Docker file is essentially the recipe to define how to take an image, do what you need to do, copy my code into it, and create an image, right? It's very much like step 1 from Node 6. The version of Node is a little bit old, but Node 6 is saying, go out to the world and find me an image of Node.js version 6, right? That's what the first line is saying to do. Go out to the internet. I don't have Node on my machine, but the world does. So I'm going to download Node 6's container and put it on my machine. The next thing we're going to do is we're going to specify the work directory. And what the work directory is saying is, run my commands from this directory. Essentially, this is where the work should happen on my container. In this case, the /app directory. In the third line, we're saying copy all the files in my local directory, dot is the current directory, for those that are not familiar with what that means, into the folder /app. So as you may figure out, what's going to happen here is any file I have in my folder test is going to be put into the directory /app. The next command is expose port 80. So basically, web servers typically listed on 2 ports, 80 and 443. 80 is your non-SSL HTTP, HTTPS being 443. It's a common thing in the world. So we're just going to say, for the purpose of this, we're not going to get into SSL craziness. We're just going to say, take this app and expose it on port 80. And the last command here is saying cmd, command Node.js app.js. For those who are Node developers in the room or have never used Node, essentially is taking the command Node.js, run it on this file, app.js, and boot up Node.js, and we're good to go. So if everything is well, we should have a file called Docker file with all these things in there. I'm going to show that my Docker file exists. It's on my container here, which is great. Well, this is the part where I am not a developer, and I don't know how to write any of this code, but maybe you all do. But I'm going to copy this command again, because there's a lot of Node.js specific code. We're going to paste that in. Again, we're going to create the file app.js. We didn't write it yet, but they did for us, which is great. I love it when people write code for me and I can just use it. So I'm not going to really go over the code. It's kind of outside of the demo, but basically what this does is it runs Node.js on port 80 and responds, I believe, hello world. Node.js responds hello world. There's probably much more crazy examples out there than this, but this is what we got. So that's what we'll do. So if everything is going well, we should have 2 files. A Docker file, which is your recipe to create your container, and an app.js, which is your code, your awesome production-ready code, ready for customers to use, right? What's up?
In the declaration of the Docker file, you include everything, the dot app.
Yep.
Put everything in dot app.
Yep.
But everything includes the Docker file too.
I think for the purpose of this, yeah, it's probably not best practice to include, but you can specify like app.js if you want to be more specific. Yeah, you can put app.js or text files or whatever you need. You can do multiple lines as well. For the demo, it's just dot because just throw it in there. It's nothing super sensitive. But yeah, that's a good call out. We should try and know what you're putting in your containers because again, the power of Docker is in its lightweight capabilities. You don't want to copy I don't know, I'm a Python developer, your entire Python installation into a container and you have 2 versions of Python in your container. I can't imagine the world of, that could be very complex, right? So you want to make sure I only want to copy my code to there. So there's clever ways of doing that and you can Google around for that, but that's a great call out. So cool, we have a recipe, we have our code. What do we do now? How about we build a container? So the command for that is Docker, the process, build a container, -t, tag. -t is a tag. Again, as you saw earlier, there was the tag latest. Tag is essentially saying the version, if you will. So in this case, we're going to do -t node-app 0.1 and dot. It's basically saying, Docker, build me this container using the Docker file in this current directory, tag it with node-app 0.1. And the 0.1 being the version, and we'll see that too. When we hit enter on this, a lot of stuff happens, and we'll go through it, don't worry. The first thing it's doing is actually downloading the Node 6. If you see what's actually really helpful is it breaks it down step by step because each individual line, let me see if I can find this. Each individual line is seen as a step. Step 1, like very much like a recipe, download Node 6. Step 2, my work directory. Step 3, add. Step 4, expose. Step 5, command, right? And you can see that output here. 1, I don't have node 6 locally, so let's pull that down. Step 2, set my working directory. Good. Add app. Good. Expose. Great. And then run. Step 5, again, each line is seen as a command. So let's get back. If everyone's following along, we should hopefully have seen successfully built and successfully tagged. It's the last 2 of the command output here. Let me see if I can zoom in. You see something like that. Successfully built, successfully tagged. Such to the point, if you run the command Docker images, again, Docker images shows all the images that are on your local machine currently, right? I also have a typo. Whoops. Sorry, typo on my side. I'm doing it again. Cool. If I do the command Docker images, you'll see a few things. Hello world. We did that earlier, right? We have Node. I didn't create it, but we downloaded it. So we still have it on a local machine. It's stored there. And we'll explain that in a second too. You should only see Node-app if you did great and you typed and you weren't me. But since I stink at typing, I have 2 containers. Don't worry about it. It's great. They're very small. It's not too big. So you should only see 3, Node app, Node, and Hello World. In fact, this is actually a good call out. Having the Node image downloaded and me noticing my typo, when I reran my build job, notice how fast it ran. It took probably a few seconds, right? Whereas the first one was like, okay, 50 megs, okay, 100 megs, okay, 300 megs, Jesus, okay, I'll download it all, right? Here, it's actually going and saying, I already have it, I'm just gonna use what I already got, and I'm gonna build on top of it, right? It's very much like Lego blocks, right? So cool, we have our images. Now what? I guess, is this it? Do we just kind of like say, we're cool, we got it, customers are using it? No, we have to actually run our container, right? So to do that, also, I should, again, for the folks who are not command line experts, there's a command called clear. And what clear does is very much what it says. It'll clear your screen so you kind of start fresh. I like doing that usually every now and then because sometimes I just see way too much cruft on my screen, right? So in this case, we're going to run Docker. So we're on the run section for folks following along. Docker run port 4000 to port 80, and we'll explain this command, don't worry. -- name my app node app 0.1. If you hit run on this, you'll get a message saying your server is running on port 80. And what most people will probably try and do is they take this and you'll get like a malformed URL weird area, like what is going on here? Like why, this is not hello world. I didn't write this. No, what you actually have to do to get this to work is you have to actually, there's a nice little thing called the web preview in the Google Cloud Shell. I found this out last night actually too, so I'd like to share with y'all. This web preview button, what it defaults tried to do is uses the wrong port in this case. We just said port 4000, right? So let's change that port to 4000 here. Oh, let me zoom out. Change in preview. If everything works well, it just, oh gosh, wrong zoom. We see hello world running. Now this is great. So I explained to kind of why when you you see this, typically when you're locally developing, you click on it and magic happens. But what just happened here? That was a lot of random flags in a Docker command. What did I just actually type? So at the end, we see a familiar term, node app 0.1, the version of the container that we created, right? Name just gives you a friendly way to name your container. Being that an image is not necessarily a container. An image is something that you can create a container from, a container runtime from, right? -p says on port 4000, go to port 80. So that's why we had to do that weird change port thing, because it's basically saying my laptop is going to talk to Google's console here at port 4000, but it's really Docker's going to serve it at port 80. So basically it's going to translate 4000 to 80. It's essentially, there's a lot of complexity as to why it needs to do that, but for the purposes of this code lab, it's basically saying go from port 4000 to port 80 on the side here. So we saw it there. The nice thing about the Cloud Shell is you can also open up multiple tabs. So there's a little plus icon as well. That's a little tiny, but like right here, you can click that. We can also see it from a command line. So curl is essentially a command line way to test your applications. Just do a quick ping and send a request. If we do HTTP localhost port 4000, we should get hello world because it's listening on port 4000. But more importantly, if we do Docker PS right now, there's our container. It's still running. It's not like the hello world one because it's still listening. I can call hello world or the URL multiple times and we got something listening. So as for the developers in the room, this is your service actually running and sending requests, right, to your application, right? It's nothing. Node hasn't crashed, if you will. You can make it crash, but it hasn't crashed yet. So right now, your container is still running. So to stop it, you have one of two ways. The server is still running here, so you can essentially kill this terminal. But the way to kind of be a little bit more prescriptive and describe what's going on, we can do Docker stop my app. Again, we're not saying node app, we're saying my container, my app. That's what we called it earlier in the dash name in the command up here. Dash name my app. We're gonna say stop my app. I don't want node running anymore, right? We're also gonna put, you know what? Let's do it as two commands because it'll be easier. And concatenates commands. I find it a little confusing, especially for folks who've never used a shell before. So just do Docker stop. What this is actually going to do is stop your container gracefully, so nice and slow. Takes a few. Cool. Such that if we run the command Docker PS, it's no longer working. We go to my browser and I hit refresh, get an error because we stopped it. That's what we expect. In fact, let's even test it with localhost 4000, and we get a failure. There's nothing listening on port 4000. The next command that they tell you to run, Docker RM, is essentially for you to clean up after yourself. Docker containers can take up space, so what you typically want to do is Docker RM my app, and it'll clean up the mess that was just made for this little tutorial here. So, in the first shell that we had opened, we could run the command Docker run. It's again the same thing. However, there's one small change, and if you look at it really closely, you may miss it. There's a -d flag. -d runs it in daemon mode. And what does that mean? As you saw, when I first ran it without -d, my terminal was hung. I just saw server running. I really couldn't do any more commands. I had to hit the plus icon, open a new shell, and do my commands. However, now I'm free. What is going on is essentially it's running as a continuous process behind the scenes, no longer locking a shell. So when you run Docker PS, you see that the container is still running right here. So this is node app, but I don't have my shell locked up. I can continue. I can do curl localhost 4000. Hello world comes back. Hopefully this should also work. Yes, the web browser also responds, but I can still type my commands. So -d is in daemon mode. It is essentially a process that is always going to be listening, not locking up my shell. This is most likely what you're going to do if you're running a production app. You don't want to have, I don't know about y'all, but I go home at 9 to 5, right? I'm not sitting at a shell all day. If I close my laptop, I don't want half of production to go down with me. So -d will keep your container running. So that was a great tour of, let me just see in terms of time how I'm doing here. So make sure, sorry, I'm not going, cool, I still have 18 minutes, perfect. So that's great from a concept of, running a container and we still have a container running, but when it comes to debugging, what is going on? Is it working? Is it not? I don't know. I hit -D. Let's see. If we do the command docker ps, well, the good news is it's still working. The status is up about a minute ago, but is it really working, right? So there's an awesome command called docker logs. And what docker logs is essentially is Docker comes with a little internal process to kind of listen in to the logs that get standard out from your application. You can also run the docker logs, where'd it go? I lost track. I resized my window and it lost me. Sorry, guys. Yes, docker logs -f. We have to copy that hash. Again, I mentioned the importance of hashes in the context of Docker. There's a container ID, 2E, mine is 2E7, right? You don't actually have to type it all. You just have to type enough for it to be unique. So in this case, 2E7. I just see server is running at port 80. I'm actually not sure if this app actually logs my requests, but it does not, no. So you'll actually see just like the command that we saw earlier, right? And right now it's just essentially listening, but my code isn't actually doing anything interesting, so it's kind of boring. It's just kind of running, if you will. So you can actually go to another terminal when running a container, and this is part of what I was talking about earlier. It can get really confusing because now I have my Linux box, which yeah, I get that, but now I have a Docker container running. What if I just want to get on that container and just do some commands? Like I want to make sure that, well, why am I getting a connection failure to the database? Or why is .NET not working in the way I expect it, right? That's when you can actually open up the terminal, and I like to do my clear command because that's way too much stuff on my screen. Docker exec, it's Docker execute essentially, -IT in an interactive terminal into the container ID. Again, I'm going to go back and say 2E7. You don't have to type in the whole thing. You just have to be unique enough. 2E7 space and the command that I want to run. For those, again, who are not familiar with the shell, bash is typically the most common implementation for getting a shell interface into a container. Sometimes it's a little bit different. Every container uses a different base image. Some may be based on Ubuntu. Some may be based on very small, lightweight distributions of Linux that may not even have bash installed, and you have to use something like sh, a shell. Again, it's very unique per install, but in this case, we're fortunate bash is installed. So again, Docker execute in an interactive terminal on 2E7, that's my container ID, bash. What I just did is I'm now essentially, if for lack of a better term, SSH'd or logged into my running container where things are actually executing, right? In fact, we can see this because I'm in the /app directory, and if we notice anything, we have our Docker file, as we mentioned earlier, we copied that in there as well, and our app.js. We can see our running code, right? So this is great because now you can kind of troubleshoot it. You can see some errors. We can like, hey, I want to see why I can't reach google.com, so curl google.com. You can get a response, you know, your internet's working, things like that. You can kind of start triaging some of your commands, right? Getting on, essentially, this is the part of like, I wish I could get on the server and run some commands. This is essentially that for the context of a container, right? So when you're done, in this case, all we did was just log in and look to make sure that the container is actually running. You hit exit. Exit basically pops you out of that container and you're back into your Cloud Shell. That was the context of debugging and logging into it, but there's also a layer on top of it called Docker Inspect. Docker Inspect to E7, and again, how am I doing 2E7? I did Docker PS. I see that there's still container ID up there. So Docker Inspect 2E7. You are going to get a lot of data. So much that I don't even know what all these things do, but you get basically everything defined for what is this container running. So I wish I could make this a little bit more readable. So you get things like the gateway, the network gateway. How are you traversing out your network traffic? You get things like storage somewhere in here. Oh, here we go. The command. Does it look familiar to run? Node.js. Any environment variables you may set will appear here as well. There's also a lot of things here, Linux stuff. For example, if we want to see the IP address of our container, there's actually a really great format command. This is a little bit of a mysterious thing. You kind of have to look at the docs to know this. But basically you're saying Docker inspect in a format range network settings. So somewhere in this JSON payload, there's a field called network settings. Go into the command networks, the next piece of data, networks, and get the IP address. So somewhere in here, there's an IP address. So it should hopefully print this 172.18.0.2 after running this. And if you copied this shell and you hit enter, you're going to get an error. There's a part where it says container ID. Change that to 2E7 or whatever your container may be. And as you can see, the giant JSON blob of data of my container got reduced to essentially a one line, like all I care about is the IP. What's great about this is, at least for me, when I'm doing this in my day-to-day, I create friendly shell scripts so I don't have to remember this, because I don't know about y'all, I stink at remembering these long-winded commands of dash format, this, curly brace, tilde, tilde, right? So essentially copy these commands and store them somewhere that you may find useful, right, to troubleshoot.
I have a question. So is this generated from like the underlying host?
Correct. The Docker runtime right now is still running our container. So when you run Docker PS, we still see a container that is actively running and listening to requests. Customers could be hitting this. When you do the command Docker inspect, Docker is going to say, let me look at what I'm actually running. I have a bunch of metadata about my container. If you just do Docker inspect and the container ID, it'll give you everything about it. I mean, there's a lot of things, again, like I said, I don't know everything in there, but if you do Docker inspect dash format, it'll actually kind of break it down.
So if you have, let's say you're not running something on a project, like let's say it's on-premises virtual machines, does that mean that you would have to, and if you want to have some resiliency, you don't want it to just be on one VM, you would have to test that container on each VM that it might be on?
Correct, and that's
make sure that like drivers or like
exactly.
external APIs is all.
You're 100% correct. So this is great. We're running everything on a local shell, but when it comes to production, I may have 100 VMs, right? I'm running in a high frequency company, right? We get customer load like nothing, right? This thing will fall over, right? But to test that, you're gonna have to log into every box, run this command, run this command, run this command, and then you may be playing ping pong trying to keep these things up. Oh, this one died. Log in, keep it up. That's where things like Kubernetes come into play. A container orchestration to keep our containers running in an effective and highly available manner. And we'll touch on that, but that's a really great point. And it's a good catch. So the last thing, there's a crazy command here, Docker inspect. It's like the next section in the debugging section of the guide. Yeah, there's like a Docker inspect. You can copy that, and it'll show you the whole thing. So the last thing is this is great, but we have a Docker image. We have to share this to the world. We need to actually use this, right? Like, how do we get this out there so you guys can use it in your day-to-day? So what you need to do is in this case, we're going to be using a registry called GCR. GCR is Google's Container Registry. It's an endpoint that's usually provisioned on projects. If not, you have to go through this process to enable it. It's a nice tutorial. This tutorial actually went through and did all the heavy lifting for us. So the first thing we need to do is Docker tag node-app 0.1. Wait. Did we build another image? I think that might be a typo. They built another one. Okay. I see. When I switched the screen, I lost it. So we'll do this. Okay. So, huh? Huh? Oh yeah, we can. I'll just start with 2. But to keep everyone on the same page, we'll just do Docker build -t node-app 0.2. I'm also in the wrong directory. Sorry. Docker build dash t node dash app 0.2 dot. It'll go ahead and create another image here in a second. Yeah, so Google Container Registry gives you a way to share your containers within maybe a context of an organization. For example, at Redbox, we may not want to share how we do charging your credit cards to the world or how we show you the best movies, right? That's very internal to us. But things like Node, most people are going to run that, right? Things like Python, that's pretty common. Everyone uses Python, may use Python in their day-to-day, right? Or Java. So that's the concept of a public registry where you can share things that you don't mind sharing out to the world. A private registry is a nice little segmented copy of things that you want to share privately with other people. And in this case, GCR is a private context of that. Does it not have to be, but in this case, it is a private repository. So if everything went well, we built an image, and I'm back here at the publish. We're going to do docker tag node app 0.2 gcr.io / project ID. This is where you have to go to the top somewhere. Oh, I gotta make it bigger. Yeah, resize it. It's hidden. Copy this long-winded ID, right? There's a lot of things that could go wrong with this, so just copy that. Paste that in there. Beautiful. Scroll down to where it says Docker publish. And we're going to do / node app 0.2. All we did here was we tagged the image on our local machine with a new tag, gcr.io, right? Such that if we do Docker images, we'll see a new image. Yikes. So we can make that a little bit easier to read. A new image, gcr.io / quicklabs, and then the whole Node app version 2. If you got an error like saying version 2.2 is not available, just do .1 as we alluded. I missed a step there, so sorry for that. Next, we want to push this image. So we tagged it, and we want to push it out to the world, push it out to this URL endpoint, essentially. So Docker push gcr.io / project ID. Again, hopefully you still have it in your terminals. If not, it's available up here. / node-app 0.2 and hit enter. So what you should be seeing now is instead of me downloading something, I'm sending something out. And in this regard, what I'm doing is I'm sending out that Docker container that I ran locally out to my GCR repository at that URL. It's for all lack of a better term, it's the URL that we specified here. Is GCR, Google Container Registry.io, because we're cool and trendy, we like the .io domain, / the project ID that I'm currently in, that can be found at the top of the runtime, the guide, / the name of the container, node-app 0.2. Network. This is fun. What's up?
The GCR.io is a private repository?
You can make it private in that context. Generally speaking, you could also make it public. Depends on when you go through the guides of setting it up, what you want to do. Like, for example, we may have an open source endpoint at GCR, but if we only want to make it locked down when you're setting it up, there's like some flags you can set, like private, public, stuff like that.
So if you wanted to publish to Docker repository, you do it your own?
Yeah, they have their own process. Like I think you have to tag it with like hub, Docker, / and you also have to log in to their endpoint so they know it's coming from, for example, for me, from Joel, right, to publish to Docker Hub. There's like a whole step. In fact, we could show that off too during the break if you'd like to see that too. So if we scroll down right now, you should be able to hit this check my progress button. And you should hopefully see a green check mark if we did great. So I don't know about y'all, but we've been looking at a lot of command line, and my brain's starting to get a little bit command line fuzzy. I just want to see if a Docker image is actually in this project or not. There's a great search by this company called Google at the top, and you could just type in container registry, and you'll see a button for container registry. If everything worked well, you should see a node app with tag 0.2 and some hash. Again, hashes are very important in the context of Docker. It's a really important thing. Along here, and just for the sake of time, it shows you how to stop the containers as well as how to remove images. I'll do one of them just to kind of keep it a little bit for the sake of time because my lab is also running out. I started a little bit sooner than everyone. Docker RMI. So Docker RM is remove I images. RMI, Docker remove images. I'm going to remove the node 6 image. So all I have to do is say Docker remove image node 6, and it'll untag node 6, and it'll also untag the SHA, which essentially means if I run Docker images, I don't see node anymore. I basically cleaned it up, and good riddance because it was huge, right? You can see the size here. It's 800 megs, each of these images, right? So again, you could run that quite a bit and just delete them. So you could do Docker. There's also a pretty cool command here, remove remaining images. This basically deletes all your images. It's pretty cool. But that's for just kind of something to keep in mind here. Docker images. Docker RM I node app. I think you should be able to do this now. Unable to delete. Cool. Docker pull, Docker run. Yep. So hopefully everyone got a green check mark. If you haven't, I'll be around now. We're at the break here. So before we kind of call it again, I just want to do a quick recap, and we'll take a quick 15. Terminology, Dockerfile. We talked about it. Dockerfile is the recipe. Step 1, step 2, step 3, right? From is usually the first thing you'll see in a file, and it's saying what to use as your base image. If everything's successful at the end of it, it'll say successfully created. That's the way I usually go about it. So, Docker images. Images are snapshots of what is defined in a Docker file, right? So all of the steps, if everything works well, you have created a Docker image. This is not something ready for customers just yet. Some base images can be found on Docker Hub. A note, Docker Hub is public. There are companies out there like Nginx that publish secure base images. If you use hacker Nginx or Nginx from a real company, odds are try to use the ones that are verified. They're usually denoted with an underscore, or the company name is like on their website somehow denoted with that. Again, you don't want to use some random person's container. You don't know what they're running, right? This is the public. But there are ways for companies that are in the field of software to publish secure images, and that's what you kind of want to look for, a trusted icon. And you'll see like a trusted badge. Container is a self-contained piece of code that's running. Again, a container needs a process that's listening for requests. If it's just printing hello world, it'll start, it'll stop. It won't do anything. But if you have a container that's running, like Node.js in this example that we saw, it'll always be there listening, listening for requests. One of the best images that I like to do is you see this around the internet is essentially a Docker file, defines what you want, you hit build, that creates a Docker image, then you run that image in a container. So Docker build, Docker run, this is kind of the flow that we just went through in this tutorial. So with that, we did a lot of talking. Let's take 15 and maybe come back here at like 2:05. We're taking some time. We're a little behind schedule, but that's fine. We have some time to kind of balance this as well. So I'm happy to answer any questions or go around, stretch your legs, get some coffee, get some water, do your thing. So. Any questions that I can help answer? Anyone that's stuck and wants to sit down, talk? I know we're going a little slow. Is this kind of too slow, too fast? Good pace. Yeah, I just want to make sure. Again, it's a lot of experience in the crowd, but don't worry, we're gonna get to some cool stuff next. So.
I just need someone to help me with
Oh, yeah.
Towards the end, it was a little.
Go and hit start lab. Let's start from the scratch. Yeah, some there. Let's in yeah, I know. The only reason I'm saying is because I have the code from the links over there. So if let's just do this. Let me do the slides. That way it'll be easier to follow. So go to the following URL. Can you see that? Or do you want to make it bigger? Cool. Let me just finish up here. Cool. In here, write that code 1S Chicago, all of that. Yeah. Yeah, it should probably find a way to get it. Let's try logging in and try that. Yeah, this is going to be recorded. If you haven't looked, you can follow it. I know. Yeah. Yeah, kind of beauty. Thank you for coming out. Yes, you there. I'll swing back. That's how I mentioned. Let me see. Hey, how's it going? Love the internet. Okay, let's see. Oh, we didn't hit stop lab. I guess. Okay. The time wasn't expired. No, yeah. So let's do this. Let's hit start lab. No, we're gonna be quick. We can just run through it. I'll help you get your credits.
My opportunity is running on for this is my app. Oh, this is why
Is it working for you? I'll be back. Yes, cool. So you have a month now. You can follow it in your own time. Or do now. Yeah. So, lovely. So let's copy that lovely crazy email. What? You're smart. That's great.
It's in Alpha.
Yes. No, neither can I. That's why I'm glad they have a copy and paste because you saw it.
That's my app is running on 44,000. So when I'm running running another 4,000. Name my app. And go from 0.1. My app. So let's see why that one didn't run. So I cannot find that. Let's see what images do you have.
No, it's fine. This is refreshing, helping and talking to someone else. While you hit all this, I'm gonna get some water. While you just go through all the acceptance. No, I'm gonna get some water here. I have my glass. Not there. Let me continue helping her. Cool. Yeah, to draw it up. That's actually pretty good. Yeah, I know it is. It's actually better because I think that's better. Cool. So yes, unfortunately we have to go do it all the time. Yeah, but we don't be that. We'll do the steps that are necessary, I guess. Yeah, the files and everything. No, yeah, because the temporary content. Yeah, yeah, I know. So, a little more up. Start from here. So once you create that new supercharging through that process. If I want to put that in a test pad and change your project name with the actual project name. We're skipping because we did all the other stuff, so I'm just gonna supercharge and start to the end to get credit. Yeah. Cheating, but I saw you were following along. Oh, and you were like, yeah. That's. Yeah, no, it's fine. The timer, I almost ran out of time myself, so I just thought I would do it a little faster.
Yeah, the worst part about that is that the image that you're pushing is massive.
It's almost a gigabyte.
Yeah, it's like an
delete. I ran into some delete issues too. When I was trying to delete all, it was like 120 tags and it was.
I couldn't push, like, I had like started pushing the image up to the ECR repository. Didn't make it. It had to start over. So it was like.
So yeah, reconnect. No, go back to that tab. It might have lost. Connection was lost. Did it switch Wi-Fi? Oh. And let's copy this here and then Meetup Cloud Shell went very much like I suspect one of the proposals next year might be like something weird, like it was like, oh, you're already logged in, and you know, that's fine. So it's Cloud Shell button. So it's still
I mean, it's really good. One of my cousins.
Go, it's moving along. The internet. What happens when people sit in the same room with the same Okay. Great. So now, do Docker push? Or actually, yeah, it's from the tutorial. Actually, you need, yeah, just copy it. Docker, push, and then paste it. Hit it. Yeah, I supercharged you here. I'll show you where we're at. Oh, I supercharged you earlier. Remember how I said change .1 to .2? That's why. So, in a second, this is what you're talking about. Yeah, now we gotta wait to get that. Yeah. Sorry. Whatever, yeah. GDG Cloud Yeah, what we're doing is now a lot of it's got. So if you push, go back to the left and hit someone. And I'm here. Hey, cool. You got credit. You're done. Yeah. So you can hit End Lab and you got credit for this. So you're back on track. Awesome. Yeah, I kind of super track. You can run through this line as much as you want. You have a whole month. So if you want to go through it again, you can. Yeah, no worries. Good stuff.
Let's look at more terminal here. So let me get my slides ready here for y'all. Let me make sure the live stream is also working too. Cool.
I guess we'll find out.
I finished it.
Huh?
I finished. I just burst through.
I know you. I'm like, because we were like gonna tell you, and he's like, oh, let's just see what happens. But
Yeah.
my guy failed. Like he ran out of time,
Oh, because it's the image network.
and you had to restart.
You can skip. You can just tag it and push, and then you get credit.
Yeah, I pushed some bullshit.
Yeah. Cool. So let's just get our seats, stretched out legs. Who's ready to type more commands in a terminal and learn? Yeah. No, this is actually the fun part. This is that was a lot of Docker stuff. And if you have to like step up and like come back, that's fine too. Again, the quick labs are self-paced. Again, I hope I'm not holding anyone hostage from like bathroom or food. Please go up, get food, come back, get coffee. I don't know about y'all, but water is right now is awesome. So help yourselves, please. So where are we at? In our quick labs, we have successfully used Docker to create some awesome production-ready containers. Not really, but we have containers. What does this mean? You're probably going to end up in a situation like this, where you just have a ton of containers, but there's nothing really of use here, other than we can run, as one of our attendees mentioned, this is great, but does this mean I have to run this on all my VMs? Do I have to log into every box and run that command that's crazy every time? What if it breaks? Wait, how do I know if it breaks, right? And that's why Kubernetes exists. It's a container orchestration platform to kind of help solve some of those answers. It comes with its own challenges, but it also does a lot of heavy lifting, and this is kind of what we'll do. So to preface with this, the lab is broken up into 2 labs. This lab is rather short. I am going to supplement it with details, But this lab is very infrastructure focused, which is cloud infrastructure focused. So it means a lot of kind of GUI driven or command line driven. The next lab, lab 3, is actually going to be using things within the cluster, right? So this is actually creating your cluster. Lab 3 is actually using Kubernetes. So, but don't worry. Let's solve container orchestration. So before we get started, we have to understand, what is Kubernetes? Kubernetes is an open source container orchestration system for automating your application deployment, handling your scaling, right? How do I make sure that my customers actually see a 200 instead of a 500 error page? And also service management, right? The context of when we do software development, we create services, and the landscape today is microservices. You may have heard monolithic services, right? They are services nonetheless, in the sense that we don't write just random code. They typically have a purpose, like a payment service, a browsing service, a registration, a login service, right? Managing those services for us. It was originated at Google as a base on Borg, but it's now part of this. Well, it's graduated from the CNCF since these slides, but it was initially its continued success has been because of community contributions. So people in the world like us giving back to the community, finding out, that is actually not working. I'm going to fix it so other people don't run into this crazy nightmare of an issue I ran into too. So open source collaboration. So many people look at Kubernetes to solve reliable deployment rollouts, faster service scaling, centralized configuration and secrets management, granular service-to-service communication. Again, maybe the login service has to talk to the user account service, right? How do they talk to one another? And ultimately having a unified view of monitoring my system, right? We saw that you could run Docker logs on your container, or Docker inspect on your container, but you may have 100 VMs in your data center or in the cloud. You're just gonna log into every box and run Docker logs on it? What if you have 3 of the same service? How do I know that customer is on that server versus this server? What if they ping pong between the two, right? We need a common way of viewing this stuff, and that's what kind of Kubernetes helps solve. Let's see. So, all in all, I mean, basically everything I'm saying is it's great. Kubernetes is awesome. Let's just run through it. Let's do this. What's the problem? It's complex. As with any great solution, it's not just as simple as getting started. There's a lot of things that kind of take into account to building a successful cluster. There's an API for your cluster. There's a Kubernetes master that controls the scaling of your work, putting work on specific nodes. You may have nodes being servers that are GPU based, right? They may have video cards for intensive data calculations. You may have other ones that are memory based for those high big data jobs that need a lot of storage to process that data, right? Or you just may have just general compute that just needs to run some workloads. Kubernetes handles that scaling. I'm not going to go into too much as to what goes in there. I'm going to share these slides, and you can read this on your own time. In fact, there's probably better material out there than this. But basically, the goal of this is that there's a lot of things that a master does if you were to do this Kubernetes on your own, right? If your boss says, we need Kubernetes in this organization, and I want you to install it. Well, look at all the things you have to kind of keep in mind. There's an API server. There's a key value store. There's a scheduler. There's a replication manager, a lot of complexities. And again, this is an oversimplification, but the goal of this slide is to show it's not easy. Well, it's not necessarily easy alone, right? Even the nodes that we talked about earlier, there's a lot of things that need to be done. You need something to run containers. You need something to handle the incoming requests to do work, and you have to figure out how to allow people to hit your services. Again, a lot of complexities, and the goal of this, we'll have a better slide on this, but the goal of this is to show it's not complex. Or it is complex, sorry. Essentially, if you don't have to run a cluster on your own, don't try to do it. It's a lot of work, especially when you're new to it. Generally speaking, I find that a lot of folks want to use Kubernetes, but they don't want to maintain Kubernetes, right? They want to be users of it, and that's what Google Cloud and GKE, Google Kubernetes Engine, help you do. All that complexity here of this monster is summed up with G-Cloud, container, clusters, create, stage. And boom, I have a staging cluster created for me. So I don't know about y'all, but if my boss told me to do one or the other, I don't know what Kubernetes is, but I need to learn it. So I'm just gonna run this one line, get it up, and see how it works, tinker with it. And then maybe in a few months' time, come back and maybe I want to run it myself. Or maybe we'll find out that having a managed service is pretty good. Again, there's right and wrong answers, but again, to get started, don't overcomplicate the issue. And I think that this is probably one of the easier ways. So, with that being said, let's get into some quick labs. If you gave a rating, give ratings. I guess these are good. If you liked it, if you didn't like it, that's the one thing I say. So hit the back button. We are going to go to the next one, Kubernetes Engine Quick Start. It's a 30-minute one, but we'll break it down. So hopefully everyone sees Kubernetes Engine Quick Start is the next lab. It's here. And 30 minutes, so I know a few folks ran out of time last time, so we'll try and keep more on time. I'll try to be more conscious of that. Apologies for that. But let's hit Start Lab. I'm going to launch with one credit. Hopefully everyone else in the room has launched or subscription. You can use your awesome 1-month subscription to Quick Labs for this demo, and we'll run through it together. So Kubernetes Engine, again, is a managed environment for deploying, managing, and scaling your containerized applications using Google's infrastructure. It consists of multiple machines and to form a cluster of nodes, right? And this lab will get a little bit more hands-on with creating that. Yeah, this is just saying that, cluster organization. I kind of touched on this with my slides. So the benefit of using Kubernetes on Google Cloud is there's some nice integrations between Google Cloud as well as Kubernetes, right? You can run Kubernetes anywhere. It's open source, so that's what we mentioned. You could do that. But when it comes to things like load balancing, I don't know about you, but I don't want to worry about how to build and provision network devices. You can use a Google Cloud load balancer. Those could be provisioned for you based on that the cluster knows that it's in Google Cloud. It'll know how to provision that for you. You don't have to worry about that. Node pools, very much like in the early slides where I talked about capacity. When you run out of memory, you're out of memory, right? Maybe your website becomes a booming success and you need to double up on size. Do you want to be the one to worry about scaling that up, or do you want a service to say, that cluster looks like it's running out of memory. Why don't I add 3 more servers so it can handle more requests, right? It can handle the scaling. And to that point, it'll handle automatic scaling. But also, the nice thing is, and I'll preface with this, automatic upgrades. It's great. They are really solid, but you want to make sure that you keep an understanding as to when you upgrade software. Just like when you're using the latest version of a programming language, when you're using the latest version of a Linux environment or Windows, you want to do your testing. You want to know what is changing between A and B. So automatic upgrades are great from a resiliency perspective because they do make sure that the cluster comes up healthy, but you should also understand every time an automatic upgrade happens, just very much like on your laptops, what just broke, right? Or what are new features that I could use? Let's not be negative. Let's say, what new features are available to me with this latest upgrade?
In the same sense, the automatic scaling, do we have a sort of how it's going to cost? How is this going to cost, like?
Costs financially?
Yeah.
Yes, and that's being in the Google Cloud Console. There's also deep, with the use of tags, you can see workloads saying, the finance team is costing this much, the back-end team is costing this much, and the front-end team is costing this much. You can get as granular as you need with the cloud billing console as well. There are some integrations to see pennies to the dollar as to how you're spending your money, yes. Good point. Also, there's the concept of node auto repair. If the node goes down, as you saw on my slides, there's a lot of services that run on there. If something just stops working, this is where node auto repair will come in and say, that node doesn't look like it's actually working really well. I'm going to make a new one, and then just slowly move people to the one that should be working and get rid of that one that's no longer working. Google handles that for you. Really thing. I mean, if you're running yourself, that's you on call at 2, 3 in the morning, getting on a call, trying to figure out why kubelet just all of a sudden stopped and why it's not running after you hit rerun, right? Not not probably the most fun thing to do. And the last thing is logging and monitoring with Stackdriver for visibility into your cluster. So you can actually see Stackdriver is Google's implementation of metrics and monitoring and logging, and we'll probably touch on that in this lab as well. It's a GUI base in the browser. You can see your logs. It's very similar to most cloud providers that have that. That's their implementation of it. So the lovely, lovely steps of opening the Google Cloud Console. However you want to do it, we have to open up the console. So what I like to do is I open the console, copy this mess. For me, I like to do an incognito window. You may not want to. I like to do this. Thanks, Carlos, for the advice. It's actually good because I hate getting signed out of my Chrome session. So however you want, open the Cloud Console. You have your username, your password, and your project ID. Hit use another account. Copy this. Hit the next. Lovely password. Sign your life away. Hit done. And let's just double check you wanted to sign your life away, so hit sign life away again. Great. I'll give everyone a few seconds to kind of get it to this point. Oh, 2 hands. Okay. Any question? Question?
Different question.
Okay. No, go ahead. We're waiting, so I will giving everyone a few seconds. What's the question?
Just problem with creating the cluster.
We'll get to it. Yeah. Live sessions. I love it. It might not even be my fault. Let's see. Maybe it is. What's up? You lost your what? Oh, you have to sign out and then use a new. Cloud Console. It'll create a new account for you. Oh yeah, sometimes you have to run G Cloud config set project and paste that ID. Sometimes you do. Someone else ran into that same issue. It's sometimes the browser. Yeah. Cool. So for this lab, we're using the Cloud Shell again. Lovely, awesome, and you don't have to install anything locally. So we're going to hit the Cloud Shell. When your Cloud Shell loads, you should hopefully see something like this. Typically, G-Cloud auth list should hopefully work. If you get permissions issues or something weird, sometimes it's this. 2 people, 3 people have already reported this, so try G-Cloud auth list to make sure you don't get any crazy errors. In fact, there's a way it'll say like G-Cloud set project, so sometimes that may be an issue too for the folks. So the first thing we need to do is we need to set a default zone. Google Cloud is great. There's over 20 some odd regions, and in those regions there's a ton of zones. Zones being split out pieces of data centers. So while this may be, to break this down to a context that we may understand, we're in the central region. Let's pretend this was a data center. That's zone A. Let's pretend 50 miles somewhere that way. That's zone B. And let's pretend 50 miles somewhere that way. That's zone C. In each region, there's the concept of zones. It's not just everything in one basket. If for whatever happens, this building loses power, you will have 2 other zones your services can run in. For the purposes of this demo, we're just going to use zone A. So you can copy gcloud config set compute /zone US central A, and if everything works well, you'll see a nice updated your property successfully message. I'm a little nervous. Someone said this wasn't working, so I'm hoping it does work. Otherwise, we're going to have some fun, because I advertised that this is easy. So a cluster needs essentially a master and multiple workers called nodes. I touched on that earlier. To create a cluster, for example, my cluster, you just got to run this. So let's just create gcloud container, and actually let me do this too. I did this earlier. Let me make my screen a little bit bigger, because this is way too tiny. I can't even see it. A little better? Maybe I can make this a little wider too. There we go. So I'm gonna clear my screen because I typed a lot. G Cloud container clusters create my dash cluster. And you'll see the lovely spinning wheel of work being done in the cloud. What's up?
Got an error.
What's the error that you see? Is there something specific? Or?
This is error, G Cloud, that container, that clusters, the project properties set to empty screen. I can take a look at the error. You have to take the same thing? Alright, I'm gonna go here first and I'll back away out.
Cool. Yeah, this is going to take some time because it's just kind of spinning and clusters being created behind the scenes. So we have a few folks in the room kind of walking through as well.
Okay, so this happens sometimes when you start the console or the project is finished loading the drop down. So I've just noticed this a few times with a couple of the other folks in the room.
Can we scale up
Maybe try to
the VM size through Kubernetes API?
as it says here.
Yes. So to answer your question, this command that we just ran, it does not assume that you're setting on that. You can set it to like how many minimum nodes, auto scaling enabled true, false. You can also set what to scale on. There's a ton of flags. We were waiting. So G Cloud. Usually what I like to see is this command. The docs for Google Cloud are great. I don't know what everything does here, but you can set whatever you want. Like you can say the maximum nodes per pool, any metadata you want to set, what CPU type you want to use. Like I only want to use Xenon or whatever Google has in their cloud. Enable various networking stuff. But for the purposes of this is a one-line create, but you could get really complex, for sure.
I'm asking because, let's say I'm running UI tests.
Yep.
And it takes 2 minutes and then I have to shut it down to reduce costs, right?
Mm-hmm.
So that's why I'm asking if I can increase it when I have load and then diminish it.
What you may, we're not going to cover it today, but what you're going to want to look at in Kubernetes is the concept of a job. You said testing? Yeah, there's a Kubernetes job, and there's also a cron job. So for example, a case that we ran into, you may want to use a cron job every night at 8 o'clock, just to make sure the website's working, right? Or every night at 10 o'clock, do a bulk insert, right? And then there's also the concept of a job, which is just basically run it, do some commands, and shut down, clean up, done. So that's maybe something you want to look at, because then it kind of meets that. But we're not going to unfortunately cover it today. That's more of a Kubernetes thing, but you could use that.
Kubernetes will automatically increase the VM size when that job goes.
Correct. If you're running out of space, if there's enough space, it won't increase. But if you do need it, Google Cloud, they'll talk to one another and scale up. Cool. So after, I'm sure maybe all your clusters are still spinning up, but if everything works, you should hopefully see. Let me make this better and bigger. Cool. My cluster in the US Central 1A. The master version, don't worry too much about that. That's just the version of Kubernetes that's running. That's the default one right now. The IP of the master, again, don't worry too much about it. The machine type, these are machine types within Google Cloud. N1 standard 1, I think, is like a 4 gig something core, 2 core, I think, server. I may be wrong on that. And how many nodes? 3 nodes. So again, as I showed you earlier in the slides, there was the concept of the master being the work that gets sent in, and then Kubernetes does the split out into various. In fact, I'll just draw that up. I'll take a page from Kubernetes. That's going to keep coming up as to what a node in this is. Master. In this case, worker node 1, 2, I'm like writing a lot. So So that's the worker nodes from that context.
If you want more nodes on create, you have to use those cloud.
Yes, correct. So again, supplementing that for now. Everyone else is good with that command, but if you want, there's probably like a node size or number of nodes. Yeah, num nodes here, -- num nodes, and it says the number of nodes to be created, default 3. You can set it to 9, 10. Just make sure you have money to pay for it, I guess. Cool. So if everything worked and you got to this far, you should be able to hit the check my progress button, and you get a green check. So we get a nice little star. So yeah, this is a check my progress button. So this is great. We have a cluster, but now what? We have to actually get credentials to log in and do the fun stuff that Kubernetes expects us to do. Again, Google makes this simple. All you need to do is a gcloud command. Again, gcloud I touched on the last very early on. Gcloud is a way to interface with Google Cloud and its various resources. The command is gcloud, and it's also in your tutorial here too. It's gcloud container clusters get - credentials, and then the cluster name. In my case, I called it my cluster. You hit the enter button, and it'll say fetching the credentials and auth data. It'll fetch the kube config. Something to understand is that since this is our project and we are administrators of this project, we have the ability to do this. But in an enterprise setting, you may not want the intern to get credentials to your production cluster. There's IAM, identity management, for that. But it's a separate topic, but there is ways of controlling this. It's always a common question I typically get around this. But for this, we're an administrator. We're all superpower here. So it's great. I love it. So we have credentials, and we have a secret way to talk to the cluster. So, go ahead.
Credentials are the same that we are using for the Google Cloud Platform.
It's slightly different. Kubernetes has a file called the kube config, and that is where your essentially your authentication data is there. It is using something like a service binding to say, oh, my gcloud command can go talk to this cluster and perform this operation, and it'll respond and create a kube config. That's why the gcloud command is used. In vanilla being I run it myself, you don't use gcloud, you use kubectl get credentials something. I forget the command, but there's a way to do that. It's basically saying Joel logged into this project, ran this command. Yep, Joel's an administrator. Get him the credentials and put it in the Kubernetes way. Yeah. But the beauty of it is, after this point, the Google aspect of this is kind of gone. You're now just talking pure Kubernetes, which is awesome. That's like the best thing. Just getting the credentials is the first part. So now that we have a cluster, let's actually deploy an app out to the world. In this case, there's already an application out there that's used for this, so we're not going to have to like build anything, at least in this lab. But there is a command to run. So kubectl, if you have never heard of that before, is going to be a command that's going to be burned into your brain by using Kubernetes. Kubectl is kube control. Kubectl is also, there's a little split of how people want to call it. Kubectl create a deployment called hello server using the -- image gcr.io/Google samples /hello-app/1. Someone mentioned earlier, like, wait, are GCR always private? No, this is a good example. This is Google making an image exposed to us publicly, so you can actually download this image anywhere you want, right? So we're saying Kubernetes, create deployment called hello server -- image equals, and then the path to the container. In this case, it's gcr.io/Google samples /hello app /version 1, right? We hit enter on that. And what is spit back, if everything is working well, you'll see deployments.app/hello server has been created. Again, the image being the Docker container image from the last lecture. We used the Node.js and we published our own. Google, in this case, is providing it for us here. Now, this is great, but I don't know about you. I want to see what I just deployed. I want to load up the website. So what do? when you're getting started, it's kind of good just to break down commands, and we'll get to something more advanced in a little bit. But to get started, you run kubectl expose my deployment hello dash server, because I called it the name hello server earlier. In fact, let me just make this bigger because this is getting really wonky to read. I'm going to specify of type load balancer port 8080. And I have a typo. Nice. This is why I don't type commands. So kubectl expose my deployment, which we created in the last step, hello server, with the command -- type load balancer. Again, provision me a load balancer and service it on port 8080 out to the world. Hit enter, and your service has now been exposed on port 8080. So if we hit this check progress, we should hopefully get a green icon showing that we ran all the commands up thus far. We exposed it, but what? Is that it? Like, how do I hit it? How do I get the data from this? Right? How do I know how to get my service? And that's done with the command kubectl get service. And this is where the magic of the cloud kind of comes into play. If you run this, you're going to get a few things like cluster IP, and you will probably see this thing called pending, unless your guys are faster than me. Pending is basically doing all the behind the scenes to spin up a Google load balancer for me in my case for this service. So we have to kind of be patient and just check here in a few seconds. Okay, there we go. So now I have an external IP that can actually test. So I could copy this and go in a browser tab and hopefully do 8080. Maybe at the HTTP. Still might not be up. Gotta wait a little bit here. Oh, there we go. Cool. Took a little bit. When you first expose a service, it's doing a lot of heavy lifting here, right? It's provisioning you a load balancer to handle a lot of requests coming in, so it takes about maybe a minute or two to provision. Fortunate thing is once you provision it, it's usually pretty stable and probably doesn't disappear much unless you choose to delete it. So if everything's working well, and again, let's kind of just start over and let's do the command again. kubectl get service. We'll get an external IP. We copy that, and in our browser, we go, and we should get a response similar to "Hello world, I'm running version 1, and the host name is hello server," and some fun bits of metadata. And that's where we're at. So we should be able to hit the create check my progress button and have a nice green check mark, because what we did was we took a service, we deployed it, we exposed it to the world, and that created a load balancer, and what we are hitting with that public IP is a load balancer. Where you would probably go from here is you would probably create a nice DNS record like mywebsite.com and point it at this, or something that people don't have to remember a crazy IP. But this is kind of the start here. So I mentioned that this was going to be a quick lab, and there's not really much here other than like maybe 3 commands. All we did here was we created a cluster, we booted it up, we ran some commands, we made sure that, hey, Google is not lying to us. They are actually creating a cluster and we could do stuff on here, right? So let's kind of wrap this up. The last command is just to clean up after yourself. There is a command to delete the cluster you created, and that is gcloud container clusters -delete, and the cluster name, in my case, what? Oh, that's just, oh, nice. That's a smudge on my screen. This is why I don't type. My dash cluster, thank you. That would have been very embarrassing. Do you want to delete? Yeah, let's do it. And we have a lovely scrolling wheel because Google is cleaning up the mess for us. We don't have to worry about it. Like, we don't have to worry about deprovisioning our VMs. We don't have to worry about deleting all the internal pods and stuff. It'll do it for us. So we just wait. How am I doing on time? Okay, pretty good. Yeah, it's a very straightforward lab. It was mainly showing creating a cluster and doing some stuff. Any questions on that? Oh, go ahead.
Just as an FYI, guys, after you submitted the API request to delete the cluster, even though it's still in a pending deletion state, you can click the cleanup checkbox.
Okay, let's do it.
Save you guys some.
Yeah, we're short on time, so this is good. So you should, as long as you ran that command and you hit the Y button, you don't have to wait for this delete thing here. So congratulations, we completed. You should have a score of 100 out of 100. We did it together. We could just end the lab because I don't care if this server runs forever. It's Google's job to clean this up after we're done. So we hit this. I like this lab, so I'm going to give it a 5-star because it actually worked, at least for me. So cool. Let me see. Okay. Yeah. So the next lab we're going to be going to is we're going to hit the back button. And you should hopefully have green check marks if you're following along. If not, and if you don't and you need more time, you could always run this at home. Again, you have a whole month of Quick Labs credits. So you can run this anytime you need to. And if you want to run it again, that's great. If you want to show your friends on how to build a cluster, do it. That'd be great. Cool. So the next one is called Orchestrating the Cloud with Kubernetes. Ooh, sounds awesome. This is going to be a little bit longer of a one, but it's the longest of the series, so we will work on it together. So first thing we're going to do is I'm going to close my tabs because I have way too many here. But I will keep this one, and I'll actually blast this because this was actually a good discussion point around how to make maybe a more complex cluster. And I'll minimize that one. Cool. And I'm going to close these tabs. I don't know about y'all, but I have a problem with not closing my browser tabs. It's just like turns into this mess of how to log into things. So I'm going to close that out. Cool. So we're going to be starting the Orchestrating the Cloud with Kubernetes lab. So let's hit the Start Lab button. I'm going to launch it with credits, but you should all hopefully see use your subscription. An hour and 15 minutes. Let's see. Cool. So an overview. In this, we're going to provision a cluster. We're going to deploy containers using kubectl. And we're also going to break it and into microservices using deployments and services. And we'll touch on what that means. As I alluded to earlier, the way we did it was great for when you're learning. But when you're trying to deploy probably infrastructure, you want to maybe define what you're deploying instead of just putting it in random commands, right? You want people to vet and check this. And checking command line arguments isn't probably always the best. So we have a small app here that we're going to be using. I guess it's called app. The Quick Lab setup is very similar to what we've done. So again, open up the console. For me, I like to take that link, go into a new incognito window. Oh, because I didn't close that other tab. Make sure you sign out before anything. So always go back when you hit the login button. Copy that awesome, crazy username. Use another account. Next. Password. Is the supplementary content helping? Because I mean, the thing for me, at least, these Quick Labs are great, but there's just copying, pasting commands. I like to kind of follow it up with a little bit of at least a diagram or something. So hopefully, if I'm going a little slow, I apologize for some of the folks that may be aware of this, but I think it helps solidify the details so you know what we're doing and take that back. So cool. Agree to sign away everything. You know the deal. Cloud Shell. We're opening it up. It's awesome. It's great. Something to also know, your Cloud Shell persists. Maybe not in these, but if you were in your own Google Cloud account, it does persist. Like if you close the browser, those files still live there. I think they clean up after 30 days of inactivity because, you know, clean up after yourself. But if you want to use this, in fact, if you ever see like Googlers sometimes carry around Pixelbooks, you're like, how the heck are they working? It's because of this. Sometimes they have this, and then the latest version of Chromebooks also have Linux on them too. So it's actually pretty cool. So I'm going to make this bigger because I can't even read that tiny print. Okay, there we go. Cool. So again, we're just going to make sure that we have gcloud off the list. A lot of folks have been getting tripped up. If you click the Cloud Shell button too fast, sometimes it doesn't know how to auto-wire your stuff. So just make sure that this is working. Otherwise, you're just going to get permission errors everywhere. So we're going to copy this. And we're going to make sure that the project ID is equal to this, which is great. GCP 0B3D B3D. Awesome. In this case, I'm going to copy this command and set the zone. If you remember in the last one, we used 1A. We're going to use 1B in this case. So US Central 1B. Again, for folks who may have not used the cloud or don't know the difference between 1A and 1B, these are distributed data centers. So 1A is very segmented from B in the event of a failure. You lose power, you're still going to be up in B, assuming your work is distributed in that regard. In this case, we're just picking the B data center. So after you set the zone and you get the successful response, we're going to type in gcloud container. You know what? I'm just going to copy because I am not typing well right now. Gcloud container clusters create IO, because IO, I don't know why. That's what they wanted to call it. We wait for a lovely spinning command to run. If you want to be adventurous and wait instead of watching a spinning wheel, you can actually go to the next section by clicking the plus icon. It'll actually open up another shell. But I'll also go back if you want to wait for your command to run. Again, Google is really awesome, and they wrote some sample code for us. Again, the point of today's quick labs and study jams is not so much to write code together as much as you don't want to see me write crappy code. It's to actually use and play with Kubernetes. So they wrote some code for us. If you've never used Git before, it's essentially a version control, a way to version control your code. But the command you need to know is git clone and this URL, HTTPS, GitHub, something long. So if you run that command, it's going to essentially pull that stuff down to your local environment, your local shell. I'll wait there, and I don't want to get too far ahead. I didn't think I was going to have to sit down, but I do. One second. Sign out. I've noticed this too on my side. I just got the same error. Sign out on the Google Cloud. Disconnected. If you sign in again, it should pick up because the Cloud Shell persists. No? We're still waiting on my cluster stuff. Did you set the region? You may need to run that region command again. Yeah. Yes. Sorry. Yeah, you do. That does not persist. Correct. So sorry about that. It's a lot of heavy lifting going on when these clusters are getting created, as you saw. So take about a minute or two. Maybe no? Maybe, you know what, hit refresh. Refresh the page. Maybe log back in.
I would log back in. Sometimes it logs, I've noticed it log out, but the good news is Cloud Shelter just rerun the command, your cluster would think, as long as your timer doesn't expire, your work is still safe. So, right now, my cluster is up. Maybe not everyone's cluster is up yet, but again, the command, the next is to get the sample code, is git clone the path here, and we're going to actually go into that directory. So the command is cd orchestrate with Kubernetes. You can just copy that. It takes maybe a second or two to clone that down. The command is ls. ls is basically list my current directory. And if, wow, that is tiny. ls, we should see a few files. We'll see things like a license, a readme, contributing, Kubernetes, and labs. The thing we want to do is then cd into the Kubernetes directory and run ls again. So you should be in the directory orchestrate with Kubernetes. It should look like this. Let me see if I can zoom in. Your path should be this. Orchestrate with Kubernetes / Kubernetes. So make sure you're in that space. We'll touch on what all these files do, but for now, we're going to just do, we're going to create a simple deployment for Nginx. Nginx, for those not familiar, Nginx is just a, disconnected? Interesting. You guys are too good. No. I would refresh the page. It may have logged you out. Do you have other browsers open, like from the, close all of them and try again? Sometimes I've noticed that, like for me, it happened earlier when I had two of the same session open. It was logging me into the old and the new and the old and the new. Maybe try also an incognito window to log in. That might work better. That's actually kind of why I'm doing an incognito window. So, in this case, yeah, try an incognito window. It may be better. No, sometimes, like for me, I had the other lab open in a tab, and then I hit start lab on this one, and I logged in. It still saw my other session, so it was like, wait, which one do I use? And it was bouncing you back and forth. Maybe it could still be that the account was still open. Again, we finished that lab relatively quickly, so that account was still active. So, yeah, that could very well be it. So usually what I do is I always do an incognito window if possible. Try an incognito window, especially when we do back-to-back labs. You know, we had a break in between the last one, so we had like 30 minutes for everything to clean up after itself. Now we're like, you know, just chucking along. So if anyone runs into the issue with the log out again, try an incognito window and log in, and then maybe that'll kind of keep you in a fresh session. So for the sake of time, we're now in the Kubernetes directory. So what we're going to do is we're going to do essentially the same thing we did last time, and we're just going to do kubectl create deployment nginx. That's the name of it. I'm going to use an image nginx 1.10.0. A little bit older of a version of Nginx, but it will work for the demo today. So, if everything worked well, you ran through this. Oh, we'll get to it. So we ran the command, we created it, and you'll see that it was successfully created. Somewhere here, should have said it, but I lost it. Whatever. kubectl create deployment. So usually if you want to see your deployments too, again, we're going to get a little bit past this, but if you do kubectl get deployment, you should hopefully see Nginx. kubectl, I forget the name of the pattern of the commands, but it's like verb based. So like kubectl, if you notice, it was create. kubectl get. kubectl delete. Very action-based verbs, and then you give it like a noun, like deployment, service,
So that's kind of going to be a common structure with things in Kubernetes land. You'll notice over time. So I have a deployment that's actually up. So now if I do kubectl get pods, I should see that there's an Nginx pod running with one pod running in that the deployment. What we're going to do is run the command kubectl expose deployment Nginx -- port 80. Again, we're going to do type load balancer. Now I'm testing my typing skills again. I need to start copying. Kubectl expose deployment. Again, we did this earlier. So if we do kubectl get services, it's going to be pending. It's going to take a minute or two, maybe a few seconds. You just keep trying kubectl get services, and after a few seconds, hopefully it'll appear on your side. What's your issue?
Did you do the maybe close some of these tabs? You didn't put it. Did you do the command? What did you do? Okay, read that. Okay. Go back to the lab. I think there's one clear thing we need to do. Scroll up. Scroll up. There's more up. That's done. Scroll down. Do compute config set. Just to make sure. Yep. Go back to the first one. And try that command. It's probably gonna say error. I've already created this. Yep. Just want to make sure. Okay. Yeah, it already exists. Awesome. So we're gonna do. You clone it down. That's fine. So I think what happened is you got logged out. Go into the setting here and do. Get there. G Cloud. Cloud container. Oh no, sorry, space container. Yeah. Space container. Space clusters. Space get dash credentials. Space IRL. Oh, did I? Okay, now try your command. It might have been that you logged you out. Try it. Bam. Cool. You're back on track.
If you got logged out with that weird session, you're going to have to do the get credentials call. So that, again, that was, let me write that down. If you got logged out, it's going to be G Cloud container clusters get dash credentials, and then in the context of this tutorial, if she got logged out and she lost her credentials, just make sure that you have credentials. Typically when you create it, you should already have it, but that was good to get back on track, so no worries. So hopefully by now, I do have an IP. I should be able to take this, go in my browser, and load this up. And I get a welcome to Nginx, which is awesome. Let's just make sure that we get our points. Cool. So, at the core of Kubernetes is a pod, and we kind of touched on this. The most common mistake when starting with Kubernetes is assuming that a pod is equivalent to a container. It is not necessarily. It's very similar and it's very misleading. A pod is a collection of one or more containers, right? A pod is, I would say it's a logical grouping of your containers. So while you can have an Nginx container you could also have something maybe like a Elasticsearch container alongside it to do your logging and metrics, or a Prometheus container along with it, or maybe another Nginx container, right? Whatever you define as a pod is just a logical grouping of one or more containers. They usually belong to a shared namespace. We didn't touch on namespaces, and again, this is why we'll supplement it with some more stuff. Usually each pod also gets one IP. So that one pod of the multiple containers gets one IP, and that's how you expose that out. But a namespace is a way you can actually segment your cluster. We briefly touched on it, but when you create a cluster, you usually have a namespace called default. And if you never ever create another namespace, all your work will live in here. And this is great when you're learning and you're getting started, but when you want to start segmenting your workloads and making sure maybe I don't want on our front-end team to have access to our back-end services, right? You would maybe create a namespace, and again, this is a hypothetical example for front-end, for a namespace where their pods would live, and maybe the one for back-end. There's tons of great material out there. We're not going to be able to get to it today around architecting your deployments within a Kubernetes cluster, but this is a common example of what a namespace can be done. So you can at least kind of segment your pods even further down to a namespace. You have a front end and a back end, and your workloads can go in here. They kind of have essentially within the context of one cluster, separating out your work so they don't crash into one another.
So, are pods then translational to nodes?
Yes. So Kubernetes essentially maintains this mesh that you see here, and those namespaces are across all your nodes. Kubernetes is what splits that off. Essentially saying that your pods may not be always guaranteed to be on all of them, but you could, in theory, if you had like, let's say 3 of them, it would probably be balanced, like 1, 1, 1, right? So your namespaces go around it. This kind of namespace, that's what kind of Kubernetes keeps within its mesh. That's what it kind of maintains for you. This isn't really like a server. Now, with that being said, you could say that nodes must always be of this type namespace, but that's also like an advanced configuration flag. Like you say that these nodes should only run this namespace. The way I would see that is for maybe compliance reasons, right? I don't want my payment service to be running on the same node as my front end, because if my front end gets compromised, I don't want a hacker to potentially get access to that. So again, segmentation. It's a rather advanced topic, and we won't get to it today though. But there is a way to do it.
So the namespace is more like a logical separation, and the nodes are the physical.
Physical. Those are bare VM, or not bare metal, but VMs that run your workloads. Correct. And that's why they can auto scale so efficiently. Because if you need 3 more of them, they just add more workspace.
So if a pod has only one IP, let's say you have a couple different containers and you have things installed that require an IP address.
Yep.
Would there be like an internal IP, or how is that handled?
They're usually when you start talking, and I think we'll actually touch it in this lab, but there's usually when you start talking service to service, you do like service inside of Kubernetes, there's a kube DNS, and you use that to communicate with one another.
Okay.
So like you'll be able to get like a DNS name, and that's how you kind of talk to one another. And
that would be visible only within
your cluster, correct.
Okay, got it.
Yeah, there's ways of exposing that out there too, but for the purposes of this demo, it's just gonna be within one cluster, correct. Yep. So there is that. Also, pods are not also just limited to containers. They could also have volumes. So if you have a static volume of like, I don't know, images or something of cats or something, right? You would create a volume, and that would be on that pod, right? Within that pod there too. Cool. So how do we create pods, right? Let's take a look at this file here together. Not my terminal. Sorry, I'm getting too much into how I do this. If we look at this here, this is essentially a config file. The joke that I always like to tell people is by the end of your, as you become more and more versed in Kubernetes, you become a professional YAML engineer. YAML is a syntax language of Kubernetes to define what you are trying to create. In this file, this is actually our first view of this, so let's kind of walk through this. We're saying at the top is API version v1. For the most part, that's pretty much what you're going to leave unless documentation tells you to change that. Basically, that's the version of the API to use within Kubernetes. Again, Kubernetes is API driven. Some things may be beta, right? So you may see sometimes if you look at new features, you may see beta associated to it. But for the most part, v1 is what you're going to see when we're getting started, and probably all day today as well. What kind of file is this, or what kind of thing are we trying to do? And we're declaring that we are going to do a kind of type pod. Again, metadata is purely metadata, just a label. The app is called Monolith. The name is called Monolith. Metadata, this you can add as many tags. Like you could say, who is awesome? I am awesome, right? You can do whatever you want there. In this case here, we have containers. We're saying that in this pod, we want to have these containers. And this one is going to be called Monolith. The image, if you recall, in this case is a new image, but this is where you would put the image that you want to pull down. Kelsey Hightower / Monolith. That's the developer of this image here. Any args being command line arguments. So we want to do -HTTP port 80, service on port 80, /health on 8081, and secret is secret. The best way to store secrets is don't do this. This is a demo, so it's great. It's awesome. Ports, right? We want to expose port 80, and we want to expose a service called, a port on health, port 8081. Another thing that we want to do is resources, limits, and we're going to say that limit the CPU to 0.2. I forget what this actually equates to. It's like 20%, I believe. Don't ever go over 20%. And memory, don't overgo 10 megs on memory. So you can do resource constraints. So you don't just all of a sudden start scaling past your compute, if you will. So how do we actually do this? We have defined this in a file, but we have not actually done anything against this. So you're going to do kubectl or kubectl create -f pods monolith.yaml. -f denotes a file. Create is saying, again, how I explained, the commands are verb-based. So kubectl create -f pods monolith.yaml. We're going to do that, and we should see a pod created. So now such that we do kubectl get pods. Cool, it's already up. We'll see 1 of 1 is ready. It's running. It's 7 seconds old. What we can do from now is we can actually say kubectl describe pods monolith. Be ready for a lot of data. So this is helpful for when you're debugging stuff. Very similar to what we saw earlier in the first lab with Docker inspect. This is essentially the equivalent within the landscape of Kubernetes. It'll show you things like, when was this started? What are the labels associated to this? What is the IP of this? What's the container ID? This is the hash of it, the image that's running, any arguments, and more, right? This is essentially a huge dump of what this actually is. Describe for me what this pod is doing. I have no idea. I want to know more about it. Kubernetes, kubectl, describe, and then the pod name. So, pods are a little bit different in the sense that we kind of briefly skimmed on it. Is that there's just a private IP address. There's no way of really hitting this from the internet. Earlier, everything we've done so far has been using the concept of a load balancer. Load balancers are great. Google provisions it for us. They handle the scaling of it. They handle the provisioning of it. They handle any firewalls you can also control. But right now, there's no way for me to hit this, right? So Kubernetes has a port forward command. And again, you don't typically do this that often, especially when you're doing services that are exposed to customers. Again, you don't want to have your services exposed to the world. This is great for internal services, if you will, right? Let's say something that you don't want your customer to hit, like a backend service. You want your customers to go through your standard load the UI, talk to my front end, talk to my backend, then talk to my database. That's the standard usual flow, right? You don't want people just to go direct to the database or something, for example. So In another terminal, again, the plus icon, we're going to run the command kubectl port forward the pod monolith port 10,080 to port 80. The reason we did this in another terminal is because it does the same thing as we saw earlier with the Docker command. It's going to lock up your terminal. I really can't type much here. It's not going to do anything. That's why we did a second terminal, for those wondering why I did that. I'm going to copy this curl command again. I can now curl localhost port 10,080 and get a message because I've port forwarded that pod out to the container, the cluster, right? Again, not typical, but this is kind of the way we're kind of going through this. In addition to that, it looks like there's also a secure endpoint, which sounds like it may not actually work. Authorization failed, and it says, uh-oh, try logging in to get an auth token from this. So using curl, we're going to do curl -u, the username. I guess in this case, the user is just user. Again, I didn't write this code. I guess that's what the service is expecting. And we're going to curl /login. It's going to say enter the password for user. And we're going to do the most secure password in the world, password. If everything works well, you're going to get a JOT token. A JOT is just a way of logging in. Again, that's outside the scope of this class. What we're going to do is store that in an environment variable called token. Environment variables are essentially Linux, in the context of Linux in Cloud Shell, store the value, this crazy token thing here, in a string for me. So what we'll do is we'll store that command token is equal to $curl login username this, and then grab the token name. So it'll prompt us for our password. Wait. If everything worked, we should be able to do echo $token. And what this basically does is shows that the environment variable was successfully set. And it's stored in an environment variable on my Linux Cloud Shell, right? Such that we can curl -h oh gosh, I'm just going to copy this because that's going to just, I know I'm going to mess that up. Curl -h, a header. Again, this is in terms of development. Header with the authorization bearer token. Again, this is JWT authentication outside the scope of this class. Log in, and based on this, I should get a response saying that yes, that token, I understand it, I know it, it works. So this is great, but you may want to see like actual logs of this service. So what is actually going on beneath the scenes? Again, you're going to see a lot of parallels between the Docker commands and Kubernetes commands. It's actually very easy to get confused between the two, but it's done because, again, less context switching, kind of having the same experience in both. So we could do a command, kubectl logs monolith. And we could see, I guess this application has much better logging than the previous one that we wrote. We got a request at /, and that returned to 200. We got a /secure. We did a /login call. We did a /login call. Again, this is just the logs of the service. I didn't write this service. So the logs, if you will, of a service that you may have written at your company or on your side, gig or whatever you do. Now, this is great, but this just dumps everything out to the logs. And I don't know about you, but when debugging issues, this could just keep going on, and I may have a bajillion lines. And sometimes I just want to sit there and watch requests coming in. So for this, we're going to open up another shell. Very similar to when we did the Docker command. That cut off. Oh, no, it's there. kubectl logs -f monolith is -f is follow, so keep it consistent thing, such that I should be able to go to my first terminal, curl this a few times, and we see our login call now. So we can actually see things like, I don't know, I'm going to do a fake one because I like to just mess around. Joel was here. I'll get a message, and you'll see that in the logs, Joel was here, was printed, right? So that's kind of a way you can kind of, there's much better ways. Let me preface with this. When you're productionalizing this, there's much better ways to do logging. This, again, is just laying out the foundation as to how these logs get generated in various things like Stackdriver or Elasticsearch or Sumo Logic or whatever tools are out there that do logging, right? These are kind of the things that they kind of listen in on and forward from there. So, this is great, but as we said, sometimes you want to debug things, right? And you want to actually see what's running on there. In the Docker landscape, we had the exec command, right? Here, we have an exec command as well, and it's great. So the command is, clear, did I type too much? Cube, CTL, kubectl, exec, execute this command on the pod monolith. Using standard input, my keyboard here, do a TTY session, essentially a shell, into the container C-C monolith. Because again, a pod could be more than one container. You may have monolith, you may have Nginx, you may have Joel, you may have another container, Suzy, you may have multiple containers, right? But in this case, I want to log into the container called monolith, because that's what we called it in our YAML file earlier. And what command do we want to run in there? We're going to do /binsh, and this is what I mentioned earlier. Don't always assume every container has bash. Some are very lightweight versions of Linux, and they may not have bash. So in this case, this only comes with binsh. When you run this, I think I did a typo here. This is why I don't type. There you go. Yep, that's why I don't type. I had a typo. Let me actually exit out of here and clear. They're trying to kick me out. Okay. Stay. Okay. I type in kubectl exec monolith standard in tty-c monolith /bin sh, and now I have a shell. And I could do clear, ls, cat. I didn't cat a file, but you get the idea. I'm now in this container, and I can actually see things inside that container. And most commonly, when you're ever debugging, is why wasn't I able to reach my other service? Well, let's try a ping. I don't know. That's usually what I do. So let's try ping, google.com. Cool. Yep, network's working, so it must not be a network issue. All right, down the debugging stack. What else do we have to do? Okay, let's try this Java command. Oh, okay, that was the issue, or whatever you do for debugging. Again, I'm oversimplifying it, but it could be as complex as you need it to be. You're on a container, you're on a Linux box. You're available to do whatever commands are afforded to you on that Linux box. So this is now, that was pods, right? And that's great, but pods, again, are not meant to be persistent. Pods are, I mentioned it earlier in the slides of like cattle, not cats. Every time you do a new deployment, you don't just log in and update the files and restart the pod and magic happens. No. You're supposed to create a new set of pods, migrate traffic over, and use those new pods, right? And if you want to fail back, you go back to your old pods, right? Pods are meant to be immutable in the sense that they should just be chucked away when you're doing new changes, right? You don't go into the running pod and update the container image, for example. You can. You shouldn't do that because that will break. Don't do that. That's going to be very bad. So essentially, this is where we're going to start talking about services. And we've been doing this actually indirectly. We've been, for the past, before this pod actually, everything else, the Nginx was a service. The Hello server was a service of type load balancer. Essentially, what a service does is, and this is actually a really good picture. Wow, I like it. Let me make this bigger. Essentially, a pod is a single pod, right? If I wanted another one, I would have to deploy a pod. Generally speaking, you don't ever really deploy pods. You deploy a service and you deploy deployments behind the scenes, and those create pods for you. A service is something to front your pods. You may have 3 pods of type hello in this case. A service will balance that traffic, whether it be a load balancer that Google creates or it's a load balancer that you create. In our cases, in our demo earlier, it was a Google Cloud load balancer, and you may have had many pods behind the scenes such that Google Cloud load balancer, request, it'll know how to balance your traffic and respond.
And as you can see in this example, it's balanced across 3 nodes. We touched on that earlier, that the work, that's Kubernetes responsibility. You don't have to, unless you choose to, tell where to put your pods. If you want to get that advanced, you can. Kubernetes will let you do that, but for now, just assume that Kubernetes will distribute your work evenly if you say 3 and you have 3, right? It'll put 1, 2, 3. So, the most common interfaces for this are, there's 3 types. Cluster IP is an internal IP of your service such that it's only accessible within the realm of your Kubernetes cluster. If you do a service of type cluster IP, don't expect mom or dad or grandma and grandpa to be able to hit it. Unless you are in that cluster, you're not going to be able to hit it, right? The second one is a type node port. Node port's a little bit interesting because essentially what you're doing is you're exposing your service at the node level, right? You're going to be able to hit a node at each node, right? That might not be what you want because you're going to have to expose it at these nodes here, right? To expose it out to the world. So typically the most common, at least what I've seen, has been of type load balancer, and just say, hey, look, I don't want to be responsible for this. Google, create me a load balancer and send my traffic to this. Done. So that's usually, each cloud provider is different. And this isn't magic. There's actually open source to maintain this. Like Google contributes this. It'll actually know, like if you do this in another provider, I'm not going to mention names, but it'll also know how to do it in other cloud providers as well, right?
But you need that if you have a production.
I would recommend it, yeah.
You have to deploy in each node a version of the application, and you keep this in production while you're deploying one of the nodes.
Yes, exactly. Using something like a type load balancer will help afford things like scaling events. When you add more resources, the Google Cloud Load Balancer has some smarts to know, well, that node isn't even up. I'm not going to even send traffic to it yet, right? I'm going to wait for that node to come up and check that it's healthy, and then I'm going to send traffic to it. There's some nice things that using like an external load balancer in that regard, a type load balancer, it affords you that. So, but generally speaking, and at least in my experience, when exposing a service to a production environment, typically it's usually going to be load balancer. In some cases, I've seen node port, and if it's truly internal, I do cluster IP, just within the context of that cluster. These are things, again, like the concept of a backend, where you don't want customers to ever hit it, but you want services within it to be able to hit it. So let's actually create a service. We should be able to, if we're already in that same directory, hopefully, but if not, we're going to go here and, where did my terminal go? Here we go. Clear. Come on. There we go. We should hopefully see orchestrate with Kubernetes and Kubernetes. So make sure you do that. We're going to hit cat pods secure monolith, and you're going to get a lot of data back. So hopefully, let me see if they actually break it out here. No, they don't. So let's just kind of quickly go over this secure monolith pod here. And in here, we'll define, where is it? Oh, no, sorry. This is actually just deploying your pods. This is sorry. So they do touch on security. Okay, I like this. Let's see. Sorry, I must have missed this on my training here. So what we're going to do right now is we're going to deploy another pod. We've deployed the pod monolith. We're going to deploy another pod called secure monolith. There's a lot of other things and a lot of flags set in there. But for right now, we're going to create a secret. I keep going back to a terminal. kubectl secret generic TLS cert from file TLS. And what this is going to do is this is going to upload an SSL cert. Again, I didn't provision this. This is just kind of something that came with the lab. Someone created a certificate. Kubernetes also has the context of a config map. I'll probably touch on this too. A config map is essentially a collection of environment variables or properties. So if we kind of quickly look at this. Oh, gosh. cat nginx proxy.conf, you'll see that I'm storing this file in a variable called nginx proxy.conf. A config map is essentially either a file or a collection of environment variables that you want stored within the context of Kubernetes. The beauty of that is you can use it for things like property files. Like if you have like a web server that has configuration, you can use a config map. Secrets are used to essentially store secrets, right, where they're a little bit obfuscated. A thing to note, and it's something as you're kind of going to production, I do have to touch on this. Secrets natively are not encrypted in Kubernetes. They are encoded in base 64. Base 64 is just essentially a layer of obfuscation of it. You could run a command base 64 decode and you'll get the password. So when creating clusters, especially in a production environment, I have to say this, make sure you have considered encryption of your secrets store. Google Cloud has built-in support for KMS, key management, so they will help with this. Especially, I have to say this because this is sometimes overlooked and you see these on the news and people get hacked and you're like, how did this happen? It's encoded by default. It's probably changing in future versions of Kubernetes, but for now, you have to make sure you consider this early on, especially when you're going into production and considering that. But for now, we're just doing demo. We're not too worried about it. So sorry, I do have to be kind of my security side coming out there. So you can limit access to your cluster through IAM. However, yes. So yes, you can limit it. With encryption too, also keep in mind, if you do have permission to list credentials, you're still going to be able to get in there. But if I was to attack the credential store from the outside of the world, I may be able to get the payload, but it's going to be encrypted. And unless I have a way to decrypt it, I'm not going to be able to access it. So yes, there are ways of locking that down, especially in Google Cloud. If you just do in GCP, GKE, like security, you'll see some of there's like a best practices doc out there. So again, we've created our config map. So now that I have all my variables, I'm going to create my new deployment. So if I look at this right, what we just did is we created another pod. So again, we had our monolith, and now we have our secure monolith, essentially 2 pods. We are going to create a service. A service is what I was describing earlier. It's kind of weird how they kind of didn't talk about secrets. So sorry if that was a little confusing there. I think I talk about it in my slides too. So what we're going to provision, again, very declarative. What kind of file, or what are we actually doing here? We're doing a service. What API version? Again, most of the time, you're going to see v1. Metadata, in this case, monolith. Spec selector. Selector is essentially a way for a service to select workloads behind the scenes. And this is why labels are important. If you remember, the metadata of the pod earlier had a label app, and that value was monolith. In fact, we can probably go back and show that real fast. If you look here, you'll see that metadata as name of label app monolith. The selector is going to know to go look for pods that have app monolith and secure enabled true. Now this is why it's very important. Remember, we just deployed another one called secure monolith, right? If I look at pods, secure monolith, forget all the complexities of this. In here, we should hopefully see secure labeled somewhere. If not, I think that's one of the labs. I think I'm getting ahead of myself. Let's look at this here. Secure enabled true. So again, it's going to look for that. If we create that right now, it's going to expose it. We're going to just check the progress just to make sure we get credit. Cool, we got a green dot. So we just created a service. So if you do kubectl get services, we'll see hopefully monolith is now running on type node port on the cluster on over 443. To expose, okay, we're getting a little ahead of ourselves. The labels, app secure. Actually, I'm wondering how this.
There might be a typo in this lab. I think I'm getting ahead of myself. I think this is going to be one of the things that they trip you up and then you get back to saying, well, why didn't it work? And then we'll get to it. So, yeah, sorry. So, like I said, you putting it on node port doesn't necessarily expose it to anything. You're going to have to do a firewall rule to allow that port to be accessed on the internet. Again, since this is a type of a node port, let me see if I can get that picture back. We're exposing it at the node level. We don't have a load balancer to handle traffic for us. We are going to say we allow the internet to talk directly to this node directly. Again, that's also another feature of using a load balancer versus a node port. Using a load balancer, you can actually separate your exposing of your services, right? You don't have to do a firewall rule, essentially.
So why don't just use load balancer all the time?
Most people do. That's I don't know. Again, it's most people do. Node port. I don't know. It's a good question. I don't know. I've always used load balancer. I know. Generally speaking, I've always seen type load balancer. Node port is great if you don't want to pay for the ingress of it, and you just need to do maybe like a one-off. Because you do have to pay for a Google load balancer. There's probably other reasons too. I don't know actually. Yeah, I've always seen type load balancer. So, yeah, good question though. Cool. So nice of Google, they included the G Cloud compute firewall command. Basically, we were saying Google compute, being the resource compute, not like compute do an operation. Compute's the name of where the firewalls live. In the firewall rules section, create a rule called allow monolith node port and allow all traffic TCP over 3100. And if everything's working, we should have that good. We should be able to check our progress and see if that command actually ran, which it did. We should be able to run the command gcloud compute instances list. Again, nodes are just VMs. Compute is the name of the service from Google and it's in the book for compute VMs, right? So we should be able to get the list of IPs and be able to get one of those. Come on. Ugh, Jesus. There we go. Come on. There we go. I think I got it. I'm going to do a command curl -k HTTPS 3100. And it's failed to connect, connection refused. So, yeah, this is what I figured. So remember how I was saying expected the label app, monolith, and secure, enabled, or true, or whatever? I was getting ahead of myself. It's actually one of the things. So, sorry, I spoiled it for you guys. Let's get all our pods with the label monolith and see what returns back. Okay, so kubectl get pods with the label of monolith. Okay, so I see my monolith. I see my secure monolith. Why is this still not working? Well, let's look for our pods. I spoiled it. Let's look for our pods with monolith and secure enabled. Spoiler alert, there are none because it's not defined. So we're going to do a label on the secure monolith pod that we deployed earlier. So we're going to do cube cuddle label pods secure monolith, and we are going to do secure equal enabled. So I labeled it with the secure enabled, again, metadata, such that if we do kubectl get pods secure monolith show, I'm getting adventurous typing.
Does that actually do anything, or is that just like a tag?
That's a tag. But it's important because, again, in our service, we defined that only service traffic with the label app and enabled true. Since nothing had enabled true, it was never able to find a pod to send traffic to. Does that make sense? Yeah. So the labels could be used however you want. In some regards, I use them personally for billing purposes, like team name equal the backend, right? But in this case, to do a service, we're saying only service traffic to app this and secure true. If everything worked, we should be able to get a list of endpoints, and let's do, oh, cool. Yeah, so we're saying kubectl describe monolith grep endpoints, so it's looking good. Let's do our command again. Gcloud compute instances list. I won. I copied it. I'm going to do the command curl -k https / external. I didn't win. I copied too much. Cool. There we go. Curl -k https / the IP 3100. Cool. We got message hello. And the reason why this responded now is we added the label. The service is like, haha, I do have a pod with the label of this, and it's also label app monolith and secure enabled true. And it's able to service traffic in that regard. So what we're going to do now is we're going to just check our progress. And if everything went well, stop dancing terminal. I don't know why it did that. Cool. That was a lot of stuff in regards to pods, but as I alluded earlier, most of the time you don't deploy pods, you deploy, it's gonna sound weird, you deploy deployments, deployment manifests, right, where that is what creates the pods for you. You are more than welcome to create pods as you need, 1, 2, 3, 10 times, however many you need. Most of the time, Kubernetes has a built-in mechanism for deployments, essentially where you say, I want my app, in this case, hello, to have 3 replicas in the case of 3 pods, and then let Kubernetes figure out how to schedule that work. So let's actually see this in example. Where is it? I lost it. Let me just make sure I'm covering everything here too. Yes, that's true. So by using deployments instead of pods, Kubernetes is able to then move your work around in the event of failure, right? If our node, let's say in this picture here, and we did this in pods, if this node died and we just did pods, we are on the hook to move it. But by using deployments, Kubernetes knows that, oh, this person is expecting to have 3 pods running in our cluster. If that dies, it'll know to spin up or move the workloads over to another node such that it looks like this by using the deployment object. If you didn't, you're going to be 2 of 3, right? You are essentially the elasticity of scale at that point. But by using deployments, you're saying to define what I want deployed and how to move that around. Essentially, I always want 3. It'll move it around to however you need.
And by moving around in that case, you mean destroy and recreate and create new pods.
Correct. Yes. Yeah, not moving around. Again, the concepts of immutability are very important because they need to be able to boot fresh, and that's commonly why you see that. So good call out. So let's actually look at a deployment YAML and how that looks. I'm still sourcing too much back to my command line. This is a little bit easier to read instead of that terminal. But if we look at this, we are going to, let me see if I can zoom in. We are saying again, what type of file is this, or what thing are we deploying? Kind deployment. API version, if you notice, haha, it did change. Sometimes they're different per service, so keep in mind, it's not always going to be V1. Sometimes you'll see extension V1 beta. It's just the nature of how that service is in its development lifecycle, whether they're new features or whatever. We are saying we want a replica of 1, which really translates to 1 pod. In that replica, we want a metadata of auth, app to have the label of auth, and track to have the label of stable. I don't know what that's going to do, but again, metadata of every replica that every pod that deploys, add this, a template on every pod. We are saying that the container that should run in every replica, every pod, is going to be the name auth, and again, an image from Kelsey Hightower, auth 2.0.0, and the port 80 and health 81 here. So let me zoom out. There's probably a lot more to this as well. So you see things like readiness probes and liveness probes, but we'll touch on that when we're not under the gun of time. And I think I do have slides on that too to cover that. It's very important in the concept of a deployment. So let's go ahead and copy that command. Let me do this. Whoop. Too much. I'm going to copy this. Adjust my screen. kubectl create -f deployments off that YAML. That's the file I just listed. If it works, we're going to get a success message. We are also going to create a subsequent service, very similar to the service we created earlier. And now do the same thing to expose the hello deployment. I guess there's another service. We're doing multiple services here. I'm not going to show these files. We can look at them in the break. And one more time, to create and expose the front-end deployment, we have to run the command. Looks like there's a config file for front-end. So it's saying create a config map called nginx frontend conf from the file nginx frontend conf. It looks like it's just an nginx configuration file, right? And we'll break that out. We'll touch on this during the break. This is where I think Quick Labs falls short. Right now, it's just saying, hurry up, you're running out of time. Copy and paste this. We'll actually take some time and look over this. So basically create services for this front-end deployment, right? Such that if we do the command kubectl get services front-end, it's still pending because this front-end service probably creates a type load balancer. I could tell because we're waiting anyways, so. Yep, you could maybe see that, maybe a little too much type load balancer, and that's why you see an external IP pending. You're saying it's going to listen on port 443. And if we do curl, well, let me see if the IP came up yet. Okay, it did. I'm going to copy this IP, and I'm going to do curl -k https / external IP. And we should hopefully get a hello response. Might have done it too soon. Cool. It just takes some time. It's like the load balancer was still provisioning for health checks and stuff. It takes about like 30 seconds. And you can, again, this is something you can configure. The load balancer has its own set of health checks aside from Kubernetes as well to make sure what it's going to send traffic to is successful. If we did everything right, you should be able to hit this green check mark, and you are going to get credit for this. So let's take a quick break here, but let me just see my slides here. Yeah, let's just do a quick recap and let's take a quick break, and then I'm sure there's going to be a lot of questions that come out of this because I just threw a lot of core content at you folks. So the biggest thing to take away is Kubernetes is declarative, and by declarative, everything is defined in YAML. You define things like your metadata, as we saw, very important when in the context of services, right? How many copies, replicas, right, do you want of your application? What image do you want to use? How do you want to reach it? Do you want to reach it on your node port? Cluster IP, load balancer. To kind of give a frame of reference, this is usually committed to source. This is typically when people say, I'm doing a Kubernetes deployment, this is typically what they're doing. Maybe a little bit of an oversimplification of that, but generally they're applying these files. There's many ways of doing this, but you're just essentially applying a manifest. Typically that's what they're referred to your cluster. A manifest being the file to your cluster. Again, a terminology is a pod. It's the smallest resource in the context of Kubernetes, right? And typically they're not created manually. As we saw, we did create them manually, but you don't typically create them manually. You use deployments to do that for you. And it's a group of one or more containers. And the way I always like to explain to people is it's like a pod of whales in the world, right? Whales travel in pods. So it's like a grouping of a whale family. I don't know what they're called, a whale family. Sounds weird. So it's like a pod. A service is a logical grouping of those pods. This is typically what's exposed to the world. I like this diagram a lot because it shows that complex of the labels being used. We see that app B in this case. I think ours was app monolith. We say app equals B and cluster those two as a service. We also have a service A, and using the label selector, we're able to select those and expose that service out to the world, right? And I think this is the example of it too. So let's take a break. I don't know about y'all, but I need water. I need to get stretched out, and we've done a lot of typing. If you have questions, let's find me, but let me get some water first. But we're almost done. There's one more lab, and we are almost done here. Uh-oh. Am I going to get yelled at? Did I say something wrong?
I'm wondering if I could share them a video of our latest data center.
Yeah, let's do
Can
it.
I go to YouTube?
Well, we have TV time.
Do we have sound? Does sound work?
Yeah. What do you want to do?
Actual cloud.
Google Cloud.
Actual cloud.
This one?
Yes.
I want to give a little idea of what's... Oh, sweet deal. Thank
It's
you.
a lemon water, if that's all right.
Love it.
See if the sound works. You get any sound?
You got to use them.
Okay.
So...
Hey everybody, just real quick while you're taking your break, wanted to give you guys a preview of our latest generation data center. Just came out, recently announced. We have a video package for it. Hope you guys enjoy. No one's seen this before, so this is first time ever.
Ooh.
All right.
Feels special. Let's see it.
What is the cloud? It's data. It's scalable. It's elastic.
It's servers, databases, and hard drives.
But it's bound in physical data centers. We're going to unveil something that completely changes the way you think about cloud. You know public cloud, and you may know private cloud, and you might even know about hybrid clouds and marketing clouds and elastic clouds. But today, now, there's actual cloud.
Introducing Google Actual Cloud Platform.
This is the world's first cloud offering running on servers in the troposphere. Inside actual clouds. It's faster, it's more scalable, it's more secure. And most importantly, it looks like a real cloud.
We're also releasing the industry-first performance feature, Storm Boost.
Storm Boost draws on the power of Mother Nature to give your persistent disks a 50% IOPS boost during thunderstorms.
And you can predict storage performance right from the developer's console by monitoring our new weather dashboard.
Or you can just look out the window.
Google Actual Cloud Platform is the culmination of groundbreaking scientific research on supercooled water droplets, technological breakthroughs in high-altitude, ultra-low-pressure chip design, and operational efficiencies related to the way we run non-terrestrial data centers.
I sleep more soundly knowing that my data is 30,000 feet above the ground.
I just love that I can see it.
This is the first step in an exciting journey. People say the sky's the limit, but we think bigger.
The clouds are so pretty.
That's not just a cloud, honey. That's Google Actual Cloud Platform.
Okay.
What is this GA?
It's out now.
It's out now? Today?
It's out now, yeah.
All our Kubernetes
Yes.
clusters are actually floating above us right now. I forgot about that.
Yeah, there's also
This is good. It gets my brain off of the...
exactly.
Yeah.
All right. We'll play this when they come back.
Yeah.
This
Go get
one's
some
good for
water.
Christmas, yeah.
And we'll have another fun
This
one.
one's more of a Christmas.
Oh, yeah?
Christmas gift coming up for Black Friday special. A new IoT product that we have out.
Interesting. Well, how's it going so far? Good?
Yeah, good. Very good. Yeah.
We had 2 slides on
Oh, yeah.
We had survey from Carlos. Oh, yeah. Don't worry about it. Okay. I think I left that slide on there for the sake of And then there's also a hiring.
We have a virtual hiring.
Oh yeah. Cool. Yeah, we did that before for our IO. Pretty good. Yeah. We'll probably resume at like 4 o'clock, and I think the last lab we can kind of crush through and 4 or 5-ish.
Sometimes it's gonna be long days, but only half day. We have touch base sometimes too long. Sorry, that mix is. Yeah, they do that a lot. Yeah.
It's worse when it goes to your house than at your office.
Yeah.
Like, it was like, had I known you were sending my boxes.
Right, nice, and you're having to plug them in here. So I was in San Francisco. So I missed it, yeah. I heard it went well. Yeah, I've been traveling a lot in between doing like Kubernetes.
Yeah, I've been up till like 2 in the morning and trying to like, I'm like, I need to get this analysis thing out. And I was in San Francisco over the weekend.
Oh, really? Yeah, I was there this weekend.
Yeah, this past weekend.
I was there Monday. I flew in Monday. No, Sunday night.
I flew in Friday night. So I go to this eclectic concert posters. So there's like a big concert poster event every year in October out there. So I flew in Friday night. Essentially slept on the streets with a bunch of other people. Because I'm not paying for a hotel in San Francisco for one night. So it's kind of camp. They kicked us out of Golden Gate Park. Yeah, so I was there for like 25 hours. So I was dead on Sunday. It like the essentially the midnight flight. Saturday night, so it took me like
the red eye.
The red eye.
Yeah, those are killer.
Yeah.
I was gonna do that last night, but I actually ended up leaving at 4 o'clock. Later about 11 midnight.
Yeah, that's right. Yeah. I'm gonna sneak one for me and one for Jeremy.
Sure.
In my bag.
Hey, did you get an invite for an event at KubeCon for Google? Special like rooftop? There was like a rooftop party type thing. Yeah, you were supposed to. I'll check that.
Shoot it out, yeah.
Yeah, I think it's maybe you're doing Spinnaker Monday.
No, Sunday, Saturday.
I think it's Monday night. They're gonna do like some.
Cool, sounds good.
Invite only thing.
Hey, how's it going?
So when I was doing this,
Yep.
I get stuck at this container creating
certification.
Mm-hmm.
Yes.
I actually was in your session when you guys had a cloud.
No, of course, because they're down.
What's going on? So that inspired me to study for the Google Cloud
I was able to
Architect
check the buttons and I got
certification.
100% on it.
I'm almost ready for it. I think.
command?
So
before I sit for the test, is there a best way to test myself?
Mind if I just take
I
note?
would, you know who I like right now as far as testing goes,
CTL,
it's very affordable. You go to
right.
Udemy. Have you ever been to udemy.com?
I haven't tried.
And sometimes they offer like their cloud architecture for like $12.
Okay.
And that $12
Unable to
includes
mount. So
whole
it
entire
looks like there
course,
may have been a
300 hours
missing
of video,
command
but
for the
two
volumes. I
practice
think there may have
exams
been a
of
volume
over
somewhere in this
100
guide
questions.
here.
Udemy, okay.
Udemy, and sometimes
Again, remember
you
how I said this is the annoying part where
subscribe
you
to
just
their
like
website,
copy it and run it and whatever,
then
move
they'll
on.
send you the
One of the
emails, they'll
commands
send
has
you
a
easy
volume.
promos,
Yeah.
11,
No, that's fine. And
99. So
again,
that's why lately
actually you got
that's what I've been
100% though.
recommending because it's affordable. Otherwise, you can go to Linux
That's probably what
Academy
happened.
or Cloud
Those
Academy,
weird
which is
Nginx
$70
configs are volumes, so
$70,
sometimes
but you'll get the whole monthly
okay.
access.
Right.
That'd be my second recommendation. Like, if you do have some budget, go that way. If you're on a little budget, you don't want to spend too much. $11.99, you get unlimited
So
access.
Udemy or Linux Academy?
Linux Academy, or there's Coursera as well.
Right.
But the thing about Coursera is they'll give you broader material, versus the Linux Academy Udemy is like this is how you pass the test.
Right.
It's like more just focused on you passing the test, versus the Coursera is more about you learning kind of everything, but then it's on your own to figure out how to pass the test.
So the test is all multiple choice, right?
It's all multiple choice.
So I don't have to code anything.
Yeah, so we have practice. I don't know if you tried our practice exams
I
that we
haven't
posted.
tried.
Try those,
Okay.
right? But the
Oh, the
better
one that you guys
that
have,
we
okay.
they're free, right? And then if you get the Udemy $11.99 deal, you might have to wait a couple days before they give you that deal. You might see it like $179. Like wait for it, and then they'll drop it to $11.99. They'll like do it for like 2 days. They'll say, oh, it's $11.99, buy now, and then the price will go up. So wait for that. And then they have their practice exams are pretty good. I took those. This was 2 years ago since I need to renew, but I actually saw a deal this weekend on the Udemy for $11.99 on the upgraded exam, so I took advantage of it.
I'll try that. Thank you.
So do that, and then also Google search, just say Google Cloud practice exam questions. And so many people have written blogs, and some people, you're not supposed to put questions up there, but some people have. If you go to like Reddit or you go to some sites where these people just put anything, that's what I did
So
too.
the test changed earlier this year.
It changed, yeah. So that's why you want to get the updated. Make sure whatever you're reading has an updated date of at least this year. Otherwise, and also read the use cases. Those use cases you see published.
Right, for those terracotta, whatever.
Yeah, they talk about different scenarios. Those are going to be the same exact use cases that they'll have on the test.
So if I read up on it.
Read up on it and practice drawing the architecture out by hand. Just say, oh, if I had this architecture, it would be cloud compute, pointing to this, and if I switch this, what are the trade-offs of the architecture? So that way it'll give you a feel of the test. So when you read the question, you already know the use case, and you can halfway read the use case, right? Because the questions will try to not trick you, but they'll say, if customer wants to do X, Y, Z, would they use one of these components within that architecture?
So I could think out the...
Yeah, you don't have to spend so much time studying the use case. At least you have it. You have one recipe thought out, and then that way they might give you a question on the
that's really good. That's something I could do right now. Thank you so
yes,
much.
sir. Yeah, Udemy.
Let's
All right.
I flew in from Toronto, so I'm going to run to catch my flight
Oh, okay.
at 6:30. I'm going to be slow.
Okay guys, so I have one more special video for you. This is just in time for Christmas. This is another product that made by Google that we're releasing Black Friday. I think this is going to be, especially for your family at home, they're going to love this one. So let me go ahead and play that for you guys.
You got jokes.
Hello, nice to meet you.
The Netherlands produce about 50% of all flowers in the world. The most famous one of all, the tulip, of course.
Flowers are really remarkable organisms. We've known for decades that they can actually communicate to each other through their root system.
For the past 2 years, Wageningen University has been working very closely with Google to use cutting-edge technology to look deeper into communication with plants.
We collected an incredible amount of information. Using automated machine learning, we turned this information into rudimentary language, which is becoming more and more sophisticated over time.
The more we listen to nature, the more we discover the amazing things it has to say.
Okay, Google, talk to my tulip. What do you want?
Water, please.
we've applied all this research into our latest product, Google Tulip.
2 granddaughters, Frances, we just had a second baby.
That is so interesting.
Finished. Nothing
More.
Yeah.
You promised more water.
At Kurtenhof, we're very excited about tulip technology. We like to know what tulips need, and what better way than to ask them.
I need water. More light.
Please improve humidity.
Please come here. More space.
Don't work on those.
Thank you.
Why are there so many more lights?
Of course, this is only the beginning. We're rolling out the Tulip language in the beginning of April, but we're already well underway with several updates. Hello?
No.
Cactus.
Leave me alone.
It's so great not to have a one-way relationship with the tulips anymore.
What is the meaning of my existence?
Tulip is a breakthrough in human-plant communication, letting users around the world communicate with any tulip.
Okay, Google. Play my favorite music. Yeah. That's right. Yeah. Drop that beat.
Okay. Google's great. So, for the sake of time, we have one last lab, and a lot of knowledge and a lot of things are shared today. I want to stress that if you don't understand anything today, we can still have a conversation after the event. It's not like I'm going to stop responding to everyone, so please ask questions, ask your fellow neighbors here, and you can also run through these on your own time too. So we covered things like deployments and replica sets. Again, this is the most common way people interface with Kubernetes. Deployments combine the concept of replica sets being how many pods you want deployed, and essentially is how many applications you need up and running. We'll actually show this too. Concepts of liveness probes and readiness probes. If you ever look, and then we may actually touch on the last one, a liveness probe is just saying, hey, am I alive? As most of us know, .NET being alive and up and running, or Java being up and running, is not the same as it being ready, right? I know from a context of my Java days, a Tomcat server can boot, but that doesn't mean just start blasting traffic at it. I need my application to work. I need it to get cache. I need it to start reading Spring or whatever it needs to do, right? That's what a readiness probe is for. Liveness probe is just making sure that, hey, I'm alive and I'm getting ready. And then readiness probe is saying, all right, I'm ready. Send me traffic. Now let's hammer me, please. So that's something important to kind of understand. It's a good picture. I'll share this as well. Yeah. When doing deployments, and we'll actually touch on this in the other in the lab, but deployments have a concept of rolling updates. And in fact, you know what? We may actually just want to see this in action. Yes, I think let's do that. For the sake of time, let's actually see this in action, and we'll touch on this back, and let's do a recap at the end of it. So give it a good rating if you liked it. If not, give it a bad rating. You should hopefully be caught up here. The last one is managing deployments using Kubernetes engine. Let's go ahead and click Start Lab, launch with credits, or you folks use subscription. Again, I have credits, you have subscription. I'm going to close my terminal because otherwise I'm going to break stuff. My windows here. Where was I? Here we go. So again, open up the console. I'm going to sign in. I'm going to take this and I'm going to open up a new incognito window because again, I hate getting signed out. I'm going to copy the username and the password, put it in the box, sign your life away. I agree. We did this again. For the purposes of this demo, we are going to be in the Cloud Shell. And you have to hit the continue button. You can also minimize this. If folks have this hamburger menu, you can click the little navigation thing. It'll just make it smaller. While that is booting up, I'm going to make my text size a little bit larger so folks can follow along. And I'm going to make this a little smaller so I don't take up most of the screen. Okay. So, as we have seen a few folks in the room gotten burned with this, make sure that off list is actually working and you see you are authenticated properly. In addition to that, let's make sure that we can list our project. And I do see that QuickLab GCP00 DAD. Great. So my Cloud Shell is set up. Again, make sure you do this. Otherwise, some people got errors of not being able to do this. We are going to set a zone. In this case, we're going to set it to Central 1A. Again, another zone in the region of Central. We are going to do git clone again on the same repo. Again, since this is a brand new account that we did, the Cloud Shell does not persist. But when you are doing this on your own time, Cloud Shell will persist. So, because it'll be your credentials, not student 2275, whatever. We're going to log in, and we're going to go into that directory. Okay, we're going to create a cluster, in this case called Bootcamp, with a minimum nodes of 5. And scopes, we are going to, okay, and it looks like this is going to do some stuff. Give it some permissions as well. I don't actually know what these flags are doing. It's giving it storage access, read the write. There is let me explain this a little bit better. So we have some time anyways. We're waiting for our cluster to spin up. Traditionally, in the sense of Kubernetes engine, you would have permissions across the cluster. Right now, in beta, there's a service called GKE Workload Identity Beta. And what this lets you do is lets you create granular service accounts in Google Cloud and a service account within the context of Kubernetes and link the two together. So instead of you saying the whole cluster gets admin, you can say this one service gets admin, this one service gets storage, this one service gets Redis, this one service gets Cloud SQL access. The reason for that is that, I don't know about y'all, it's always the concept of least privilege, right? You don't want some intern's container to have full admin of Google Cloud, and then whoops, I deleted the whole SQL database or something crazy, right? That's a lot harder to explain. So this is great, but just to know, it's called GKE Workload Identity Beta. If anyone has questions, I've already went through some of the headaches of that. We could talk about that after. We won't cover it here though. And we're waiting. I guess while we're waiting for that, let's open up another tab because this is just going to take some time. No, we're still waiting. Let me see if I can actually. So we're waiting for the cluster, but I'm just going to use my personal cluster, which I use. There's a command out there called kubectl explain deployment. Explain does very intentionally explain what is a deployment. So if I'm using my local terminal because we're still waiting just for the sake of time. I want to show what this is. It will actually explain what is the API version, what is the kind, metadata, spec, status. You can then use these as well and say, hey, what's spec? Go in Google and stuff like that too. But you can also do kubectl explain pods, I think. Yeah. So almost every item in Kubernetes you can explain and kind of get at least it's like a helpful text out there, right? Also, I think, it does do this. Cool. So it actually shows you every single field you can set with the -- recursive command. So when I did explain, I like this because I actually learned some stuff new. Explain gives you a lot of high-level things, but like I said, I want to know what spec is. What the heck is spec? If I do -- recursive, let's see how good I am at looking at YAML. Spec, where are you? There you go. Spec is an object which has affinity, which has pod affinity, which has pod anti-affinity, containers, args, the fun stuff. I would not. You could use this to supplement your knowledge as you kind of go through the Kubernetes stuff. But for example, if we want to know containers in this regard, we can do kubectl explain deployments dot spec containers. I think that should. That didn't dive with the field in. Whoops. Spec. Oh my gosh. Let's use their example. I know that one will work. I can't really YAML right now. Sorry. kubectl explain deployments dot metadata dot name. We've seen this before. We've used it in the past. The name space to deploy this to. So this is going to be a unique name. Most of the time, if you don't specify this, it'll go to default. But if you want to target a deployment to go to the service backend, for example, as we have here, or if we wanted to go to service FE, we would do name FE. So deploy these pods into the FE namespace. Let's see if our cluster's done. Cool. So back to Cloud Shell. The only reason, again, I hopped into my own is because for sake of time, I want to make sure we cover content as much as possible. So we're going to create a deployment YAML. Typically in the past here, we've been just copying and pasting. Here we're going to be using VI. Don't be too intimidated, but it is an editor for command line. You are going to hit the letter I for insert, right? And now that you have done insert, you can now edit fields in here. The field that we're going to edit is we're going to go to containers and change the image from auth2 to auth1, right? If people have done this with VI can be a little intimidating and very confusing. So I go to the images line, change it from delete 2 to 1, hit the escape key, the escape, :WQ, and that will write and quit the file. Such that if we do cat, we should see that the image has updated from 2.0 to 1.0. Right? And we covered this in the last lecture. So basically, the only thing we did was we changed the image type. So we're going to deploy this to our cluster with kubectl create -f deployments off.yaml. That's the file we just touched. In a few seconds, we should hopefully start seeing pods with the kubectl get deployments. Still waiting. And okay, cool. After you create it, it takes about a few seconds. You'll see that the pods are up. Auth is deployed. We should be able to do replica sets and see that there's an auth replica set with a desired count of 1, a set of how many do we have currently, and how many of them are ready. 1, 1, 1. We're going to do kubectl get pods. And you're going to see that 1 of 1 is ready, and it's running, and it's been about 43 seconds since this thing booted up. The next thing we need to do is we're going to create a service. Again, this was already created for us. So we're just going to do kubectl create -f services auth. It looks like they also want us to deploy another deployment of hello.yaml and services for hello.yaml. This is just, again, another microservice that was developed. So we're just going to paste that in. And finally, we're going to also deploy our front end. Remember, the front end was an Nginx server that had a configuration file and a secret being the SSL certificates to serve up on the internet. So just copy that and paste it in. So we've created a config map. So if we do the command kubectl get services front end, you'll see pending because it's creating a load balancer right now. We wait probably another second. A few seconds. After a few seconds, we'll get an external IP. Copy that external IP, and we do curl -k s https. Again, we're waiting on the health check, so it's going to take a little bit. Just give it another second. There we go. Took a little bit, but this is essentially the same thing we did at the end of the last lab. So again, just to walk through, we updated auth.yaml from 2.0 to 1.0. Again, changing the image. We created it. We got our deployments. We saw it. We saw that it was up. And then we deployed all the other ones like hello and front end from the same example. We didn't really go much into those, but those are, again, our microservices we didn't write. They're just services that are provided. If everything goes well, after a few kubectl get services front end, we should see an IP come up. We took that IP and we did curl. Lost it. Curl ks https external IP. And we did a curl and we got hello back. So we hit the check progress button and we get a red, green checkbox. Woo, points. So, sorry. We're about to scale a deployment. So let's look and see. Replicas, integer, number of pods. This is a pointer to distinguish between explicit and 0 and not specified. Defaults to 1. If you don't specify the number of replicas in the deployment, it would be 1. If you want to make that 3, you just change replicas to 3. In this case, there's also a really helpful command called kubectl scale deployment hello -- replicas 5. And you basically hit this. And what this does is it modifies the current deployment in the cluster and makes it 5 pods. Such that if we do kubectl get pods, one of them is still looking like it's booting. Cool. We now have 5 hello pods because we scaled the hello deployment from 1 to 5. Typically, best practice is to define this in a manifest and have your delivery pipeline make this update. This is great, in my opinion, from when you're in a position of thing is just broken and we really need service. We don't have time for this. We need to kind of hammer this. I would say do this. I always like to do my changes in a manifest to track like an audit trail of when was it scaled, who deployed it, when did it deploy it, right? You can do this in the event of an issue or whatever, but I would always recommend kind of using the manifest approach. So we saw the get pods return fine, so we have 5 of them. So as I was alluding to before I interrupted myself in my slides, there is a concept of a rolling deployment. Say you have a deployment today. Oh, go ahead. Is your cluster up? Is the cluster?
Did you do all the other ones too? Like there's a few other microservices that can be enabled too. If you look, there's a few other. Can you just run all those as well? You guys do it again. Sometimes I've noticed. Yeah.
So I'll go through making a change to an existing deployment. Again, this is great for the context of a demo, but again, I would always say that you should make your changes in a manifest and deploy those manifests out. But for the case of learning and understanding what we're actually modifying, we're going to do just an edit command. Again, Kubernetes and its command line interface is very, it's driven around the concept of kubectl, kubectl, verb, noun, do something, right? So in this case, we were at here. Kubectl, edit. I'm going to make an edit to a deployment. Hello? This is the actual deployment that we deployed earlier. In the line image, if I can find it, here, change image container to 2. Yes. So we're going to make this from 1.0 to 2.0. We're going to save this. Kubernetes deployment extensions hello has been edited. If we do kubectl get, I gotta be quick here. Let's see if I can catch it. Get replica set. We'll see that 10 seconds ago, I deployed a new set of pods, 3, and I also have my old set of pods, 3. And I'll draw this up because it's actually probably one of the best ways of explaining it. We can now do a kubectl rollout history deployment at YAML to see the history of what happened. Revision 1 was rolled out when we first did our initial deployment. Revision 2 just happened because I edited the file. Kubernetes saw that and said, I need to provision a new set of pods. Again, we don't go in and modify the existing pods, we create a new set of pods. And hopefully, yes. We see that traffic has failed over from the old deployment of it used to be 5. Now there's 5 of the new deployment here. The reason why a rolling deployment is important, and in fact, let's draw this out. And in fact, I actually have a picture. Why am I going to draw this out? I already have a slide for this. This is like arguably one of the most confusing things if from the concept of immutability. Let's see. So we have a service and we're doing a new deployment. You could see that purple is denoting a new app. So this is the current, create a new pod, rollout 1, delete the old one. Essentially it's saying, this is our current cluster, and for the sake of this demo, we have 3. Let's say these are nodes, right? Version 1. A rolling update will provision version 2, kill version 1. Provision version 2, and kill version 1. Provision version 2, and kill version 1. Essentially, it will roll out your update gradually, right? So you have your 1, 2, delete, 2, delete. You kind of see it in this visualization. And that is what a rolling update is. Now, this is why liveness probes and readiness probes that I touched on are important. It will not perform any operations of the existing pods until it passes its readiness check, saying that, yep, it is ready. It is actually working. It's not broken. You don't want to be in a situation where you deploy a new edit and it breaks. Oh, cool, thanks. More colors. You don't want to be in a situation where this just doesn't work.
Why am I going to destroy a working system for a pod that isn't even ready to take traffic, right? So that's the concept of why readiness and liveness probes are ready, such that, and again, just to visualize it, this is something important to understand. If 2 comes up and it doesn't pass the readiness, let's just say it keeps dying. Right? So someone had a pod that was dying, container failed to create. Why are we going to kill the working production website? Like, what's the reason for that? No, it has to be ready. So such that 2 comes up, perform an action. 2 comes up, perform an operation. 2 comes up, maybe finally get your readiness checked. It's something to kind of take into consideration there too. Cool. Now, with that being said, you can also pause a rolling update, such that as that we unfortunately I explained too much, so I couldn't pause this one. But you can say, if you detect that there's a problem, maybe like halfway through that rolling update, you can say, hey, wait a second, stop. You're just making it worse. Customers are 50-50 failing right now. Stop it, stop it, stop it. kubectl, rollout, pause, deployment, hello. And it's going to pause that change you just made, such that, unfortunately, I didn't pause it in time, but it would say like, it stopped 2 of 5 or whatever, right?
Can you roll back?
There's we'll get on that too. It's right here next.
Can you serve the calls like automatically when you like roll out node 1 only, and then when that
Yep.
means you continue?
We'll touch on it. So right now what we're talking about is the terms of what does it mean to deliver a change, right? Just because the service is up doesn't necessarily mean it may be ready or maybe better, right? There may be performance things you want to look. Is this service that I just deployed more performant? Can it handle more requests? Or am I seeing a slower issue or something coming along the way? Just to kind of wrap this up, and we'll touch on that. That's actually one of the last things we'll do here is a canary release, so you can kind of see A and B. But you can also resume. I'm going to do this, and nothing's going to happen because it's already done. So sorry, I had to draw that up because I did want to hammer that home. I'll make sure folks understand this. If you do this, you're going to see it was successfully rolled out, my change. So sorry, I didn't have an impressive stop there. To roll back, yes, you can do kubectl rollout undo deployment hello. And what this will do is it'll roll back to the last revision available to you, such that if we do rollout history deployment hello, it'll create a new revision because it rolled back to that revision, version 1 in this case. We can copy this command and see it. That version, oh cool, we did catch it. Right here, check this out. See how some of the pods are now version 1 and version 2? It's in the process of rolling back to version 1. Remember, the change I did is I went in, made it version 2, it made its rollout, and now we had that version 2. I did a roll back, and now version 1, such that I hope. Cool. Now they're all version 1. See, you can see the difference there now. It's rolling it back. So this is where there are some advanced deployments. Again, there's a lot of great articles out there, a lot of great technologies out there that help with rolling out changes in Kubernetes. Some things to consider. This is a great way to get started, but I think there's a lot more you could supplement with this. For the scope of today's study jam, I think let's keep with this, but maybe we could chat more towards the end around some of these services. So let's look at this new deployment called Hello Canary. In here, hang on. Let me make sure this is right. First, create a new canary for the deployment version. Make sure you update the version to 1.0 if your version is pointing to any other. Version 2. Oh, no, but we rolled back, so we want version 2. Okay.
So let's go ahead and deploy this new deployment such that now we have a new deployment Hello Canary. So if you do cube, CTL, get deployments, hopefully, yeah, you see hello and Hello Canary. We wait a little bit. And if we do get pods, cool. Right now, we have two deployments deployed. We have our hello and we have Hello Canary being the new service version 2, and we have our old service version 1. Let me do that command here. So, thanks. We have hello. State. We have Hello Canary, which is version 2. Sorry, I didn't do a good job zooming in there. Yeah, we have Hello Canary, which is version 2, and we have hello, which is version 1. This is our rollback code, right? We caused an issue, we figured it out, we have version 2 out there now. We can verify this by doing curl a few times. Hopefully in a few, there we go, we caught it. We're doing the curl command, let me make this bigger here too. A few times, version 1, version 1, version 1, version 1, come on. There we go, version 2. We basically round robin. 1, 2, 3, 4, 5, 2. 1, 2, 3, 4, 5, 2. It's essentially a way of now 1/5 of my, in this case, 1/6 of my traffic is going to be serviced to version 2. Everyone else is going to get version 1. So it's a way of kind of balancing out your traffic. With that being said, it's a great way of rolling it out, but there's going to be a question and we'll address it too. So let's just check our progress to make sure we get our points. That's what we all want. This is great, but I don't know about you. If I went to, I don't know, Netflix.com and the page was black, and I load up the page randomly and it goes red all of a sudden, is that correct? Like, and then I refresh the page and it goes back to black. Shouldn't a user have a consistent experience such that maybe this user is canary and we only want to see red, right? There is a way to establish something called session affinity, essentially sticking a user, like my laptop, to one pod or to one set of deployments. In this case, it's this flag here, session affinity client IP, right here. In our service, we say that we want a spec, select all services called app, service port 80, and bind people by their IP that they're making the request from. It's a little bit tough to explain here, and we can't show it. You have to kind of take our word for it, because the problem is that my Cloud Shell only has one IP, right? If I keep making a request to Kubernetes, what's Kubernetes going to see? One IP. If we somehow had a way to show maybe 7 IPs, I bet you if server 1 made a request, server 2, server 3, server 4, server 5 would be bound to that. So we unfortunately can't demo it. This is a very simple way of doing it. And again, there's a lot more better ways, and we'll talk about maybe some of that if we have time. Cool. We do have one last thing to talk about, and this is a blue-green deployment. Blue-green is a little bit different than than rolling, in the sense that with rolling, it made a change, updated one, made a change, updated another, made a change, updated another. With blue-green, or red-black, or however you want to call it, because there's a lot of terminology, they all mean the same. Red-black is we have our service, and we have version 1, version 1, version 1, right? What this will do is it will make a new deployment, version 2, version 2, version 2, let me draw some nice boxes. And the service will add this to your existing service and stop this connection.
Typically, this will also stay around and won't disappear. It'll be there for probably a specific amount of time. The reason this is preferable is in the event that you make a change and you need to roll back immediately. You don't no longer have to wait for pods to boot up. You don't have to wait for Tomcat. You don't have to wait for .NET. This never died. It's still there. So let's say version 2 rolled out. I'll just do a line. Version 2, 1, 1, 1. We still have our traffic there. Critical mass, it's broken. Fail back. Destroy, destroy, destroy. So maybe I should use red. Destroy, destroy, destroy. Roll back. And immediately you're back in service. Maybe there's some connection draining, some things that have to happen, but generally speaking, you recover faster. It's a little subtle. It's a little subtle, but something to consider as to why this might be a problem is you need 2x capacity on your cluster. What did I do? I have 3 pods. I need to be able to run 6 pods to do a single deployment. Whereas before, yikes, it's crazy. Sticky paper. What do we do here? Create 1, destroy 1. Create 1, destroy 1. So at most you'll need an N1. Here, you need N times the size of your current deployment. So if this was 100 pods, something crazy, you need another 100 pods. You may not have the resources on your cluster to support 100 pods. So this is why planning your cluster early is important. So again, I'm doing a lot of talking here and not so much typing, but this is something it's more or less core to understanding delivery in Kubernetes and immutable. This spans not just Kubernetes, it spans like load balancers and VMs as well. It's a little bit DevOpsy, if you will.
So what if there's a bug and you need to roll back?
Mm-hmm.
Well, I guess I have a 2-part question. In blue-green, does session affinity still apply?
It will clear. It should clear and fail back to the previous because there won't be a backend to service that user.
Okay, so part of the remediation is to kill that current session and then.
Correct, and that's typically most load balancers, at least cloud load balancers, have something like it's like a connection draining time, like how long to wait before flushing that, and you can have affinity for like 5 minutes, 10 hours, a year, right? Typically they're set pretty light to your backend requests. Yeah. And to further that, there's a lot better ways of doing this too. So again, and actually, oh cool, they did add it. You need 2x of the resources when doing blue-green. It's defined there in the red box. So let's just kind of see this in action. This one's actually a little bit easier to explain because you can actually, Joel, get out of your shell. You're not at work. We're going to apply. Did I not do something here? Cool. I applied services blue, so if I do kubectl get services, I should have a service hello blue here somewhere. Oh, here we go. Cat services hello dash blue version 1. We're going to update this deployment to be kubectl hello green, kubectl get pods. Cool, we have our green pods here now. This is missing something. Sorry, I'm just trying to get a little bit localized as to what the commands I'm typing so I can explain it a little bit better for you folks. So if I do hello blue, selector hap hello version 1, but it will not match the green deployment because it will use a different version. Green, I guess, uses service deployment. Hello green. Sorry. Hello green. What version? There we go. So that's the reason why hello blue won't actually see the traffic because this is version 2. Version 1 is the selector, so it won't, like, even though they're up, traffic isn't going to be able to hit it. So we create it. We did that already. Once you curl, you'll find that version 1 is consistently served up. I can run this here for a few hours and it'll still be 1.0. Now, if we apply services hello green, version 2, version 2, version 2, version 2. If I want to roll back, crud, the website's down. Operations team is on our case that we just rolled out bad. Customers are lining out the door that stuff isn't working. Apply back hello blue. You curl it back, you're back to 1.0. Now the problem is, if you do kubectl get pods, I mean, it's not really a problem here because we only have one of them, but we have green and we also have our standard hello, right? So now I have 2x the capacity that I have to worry about. I have to make sure that I have capacity for both my green and my existing deployment, right? So something to consider, again, especially early on when doing a cluster. I did this already, spoiler alert. I cube applied hello blue and it rolled it back. And with that, we finished. And I kind of did a whirlwind tour of that last one, but I think I hopefully did everyone at least understand this. These commands, you can copy and paste them. There's, again, tons of blog articles out there. But does everyone understand at least what I drew up on the wall here, or any questions on that? Go ahead.
You still have the links. How do you think them replace, for example, for a third version?
Well, so for me, like if I wanted to delete this, again, this is not in the tutorial at all, but I would just do kubectl delete deployments hello green, and eventually, hopefully, it's gone. Well, it's terminating. See.
Yeah.
And in a few minutes, it'll be gone. Yeah, Kubernetes will get rid of it. Yep. Let me just go back to my slides and kind of just recap this here. So present. Again, we talked about rolling deployments. We drew it up. We kind of went through it. It's important. It's not just a Kubernetes thing. It's a global deployment methodology. We briefly touched on this. Kubernetes, we touched on the scale command. Again, this is a little bit advanced, but I do want folks to kind of understand the power of this. Kubernetes also has the ability to auto-scale your pods. So in this command here, Kubernetes auto-scale my deployment nginx with a minimum of 2 and a maximum of 5. Now I have a boundary of I always want 2 and I need 5. Only scale when pods hit a 50% memory, or 50% CPU. My brain is being fried right now. But scale up my pods. So if 1 and 2 are now 50, add a third one. Now they're 50, add a fourth one. Add a 50, add a fifth one. Now we're in our bound though. You can't scale anymore because you did not say that you needed more. This is built into Kubernetes. There's a few resources, like you'll see, this is a really confusing slide, but I'll share it. There's a list of resources you can use. Like I know memory, CPU, and then I guess you could also expose custom metrics as well to the auto scale. And this is some things like within Stackdriver. Like for example, if you have a custom metric in your application like successful logins in the past 10 minutes or something, you could scale on that, right? Knowing that maybe after 100 successful logins in 10 minutes, your service is going to start getting performance hit, right? That's an advanced topic. Something within Google Cloud, it's specific to Google Cloud Kubernetes engine, is the concept of, we've been talking a lot about horizontal scaling. In some cases, you will need to vertical scale. In the events I could see this, or if you're running something like SAP, SAP does not probably like just having 50 versions of it. It probably needs to grow vertically. Like I need to just keep feeding it. Like, hey, you had 2 gigs, here, take 6 gigs more. Here, take 18 gigs. Hey, take 100 gigs. So you can scale a pod vertically, not your nodes, your pod. Your nodes, obviously you need to have compute and stuff like that too. With that being said, Kubernetes also has node auto-scaling. So partnering these two together, you can have node auto-scaling to handle when your resource pool, let's say you have a pool of a cluster of 32 gigabytes, and you're almost at capacity, it can add maybe another node to give you 18 more gigs so you can keep vertically scaling. Typically, most people will use horizontal scaling. Vertical scaling, again, are for very specific workloads. Horizontal scaling is typically most immutable. I kind of see vertical scaling with a lot of stateful workloads where you just can't destroy an instance. You have to do some sort of migration plan or something along those lines. But with that, we're on a boat, and we did it. Some bonus round stuff, we're done, right? We did this for one deployment, right? And it's this, you're at a larger organization. 3 developers come to you, you take their YAML files, you run it. Okay, well, I'll just hire 2 more people. Now you have a team, a company crazy on YAML that's just feeding it to your operations team. No, make it stop. I don't know. Why am I just getting emails of YAML files every day? There has to be a better way. Otherwise, you're still back in the same situation we were when we did the Docker example, right? So for me, in the Spinnaker community, there's a great tutorial in the Kubernetes lab, but essentially Spinnaker was an open source project from Netflix. It supports all the various cloud providers in one, so you can see your AWS, you can see your GCP, you can see your Kubernetes, all within one. There's also support for automated canary analysis for some advanced rollouts. Again, it's something I alluded to being more than just Kubernetes commands. And it's in an official continuous delivery foundation now. It's one of the big ones out there. Basically, it's a business process pipeline. You basically say, first, create a pod. 2, deploy it. 3, create a change request. 4, email QA. 5, whatever your company needs to do. Essentially, you lay it out, and you have essentially pipelines to deliver your software. Here's a good example of it. Bacon instance. Do I want to deploy? Yes or no. Create my infrastructure, deploy it, run quality tests, and generate a change request. This is a very kind of vanilla pipeline as to what you could see within Spinnaker. It's multi-cloud. You can see here at the top, it's Kubernetes. Down here, it's another provider from Google or some other provider out there in the world, right? You get a centralized view of your applications. Again, run your infrastructure where it makes sense. You could have a centralized view as a developer. Less context switches is awesome. But basically, it looks like developers commit, Git triggers a Jenkins build, at least for something I'm used to, push that to a registry, Spinnaker sees that change and pushes out your change to your Kubernetes. And again, this is in the slides. I'm going pretty fast. So with that, I say your mission, should you choose to accept it. If you notice the last lab in this was offline, a lot of folks are like, hey, what's going on? How can I do this? There's another one called Managing Deployments Using Kubernetes Engine and Spinnaker. You should look for that in the console. It's pretty cool. You can kind of see this in action and get a nice GUI and play with it too. It's a pretty cool lab. Some helpful tools. When you're debugging, you're going to want some nice way to see your pods. Other than remembering abstract kubectl commands, there's a thing called K9s. If you just Google K9s, you'll find it. But basically, it gives you a nice, pretty way of seeing, oh, running green, good, red, okay, something's wrong. You can view logs. In addition, there's also a way to try out services with something like Helm. Helm gives you an easy way of Helm install Vault, Helm install Kubernetes, or sorry, Spinnaker, Helm install Prometheus, whatever. It's essentially like a package manager for Kubernetes. Kiali is another tool out there. If you ever choose to go into the realm of Istio, it gives you nice, pretty flow graphs like this. So this is one of our samples. So you can see traffic flowing in. If it goes red, odds are something's not working. Call the operations, what's going on? You know, sound out the alarms. With that, everyone in the room, for completing today, you have a month. If you successfully complete the whole thing, if you didn't complete it today, that's fine. You have all the time in the world. Finish your journey, you'll get another month of Quick Labs. If you want a month of Coursera, we have that as well available to you folks. Coursera is like a more video-based versus hands-on. I like to have a balance of both. Sometimes I'm at the gym and I just want to hear someone tell me about Kubernetes or something. This is a great way. Take advantage of Quick Labs. We did a lot of things on Kubernetes, but I also understand that a lot of people here may not be container people. They may be big data people. There's a lot of Quick Labs on BigQuery. There's a lot of Quick Labs for data flow, data fusion, a lot of cool things out there in the data space. So if there's data engineers in the crowd, sorry, thank you for hanging out with us, but I know there's probably cooler things for you folks to check out, and that's what they're there. Even Coursera has that too.
How do you get the Coursera thing?
Uh,
I already have an identity, but I don't know.
I think when you go here, it'll say like you have completed your quick labs. Like it's click here and it'll bind your account somehow, something like that.
How much time do we have?
A month. We give you a free month.
From today or from?
Whenever you click that link and you bind it, you click enroll. Yeah. I'll share this out too for people to have. There's a survey. It's really important. Look, this event was graciously hosted by Google. A lot of great things. And a lot of folks learned, so please take the time and fill out the survey. Carlos, you want anything?
Yeah, exactly. Yeah, like to Joe's point, the biggest point is the more feedback we get, the more data you get, the more they invest in Chicago events. West Coast, they have events almost weekly because they get huge attendance. So usually all the marketing dollars go to the West Coast. So I'm trying to get the Midwest to get a big chunk of those marketing dollars. So please definitely spread the word about these events, help us raise attendance, but definitely, more importantly, give us your feedback, the good, the bad, and ugly. All right, me mostly, not Joe.
That's what Twitter's for me. You can yell at me on there
exactly.
if you want.
Yeah, so hopefully you guys enjoy this event. It's a lot of work behind the scenes by Joel and friends to make this happen, but please give us your feedback, whatever it is, all right? Yeah, let's round of applause for Joel today. So. So hopefully you guys all got that. Maybe we could send them a follow email.
Yeah.
We'll post it as well.
For sure.
But the other thing I want to talk about is I know some of you guys, just like me, would want to work for Google at some point, or a tech company like Google, or want to be a software engineer or a cloud engineer like myself. We have this virtual event coming up October 29th. We're going to hire hundreds of more resources here in Chicago, so you definitely want to be in the mix. But learn what is, if you want to do my job, go to this event. This will be a live stream event, a virtual event, and hear about what it takes to be a customer engineer at Google. Okay, or it translates well to other big companies as well. Okay, so definitely take advantage of that event. All right, cool. Oh yeah, we got a little takeaway there.
We all hung out to the end.
Yes.
I don't know if you all completed or not, but you all definitely deserve a pat on the back. So this is a lot of thinking, a lot of Kubernetes, whatever, trust me. So thank you all for coming out to the event. Most of these events are usually monthly. I got more for you. We host events monthly. We have our upcoming SRE event next month.
Oh, yeah, I forgot to update that. I usually supposed to say Kubernetes.
I just wanted to give you the chance to live edit it and hide the thing. No, I just wanted to let you know. That was easy.
Thank you for the call.
Yeah, absolutely.
Everybody got one?
If anyone also wants to develop this guys, talk to your teams, back to your respective.
I think that's it for, I think everybody's done.
Yeah.
By all means, please, we have more available.
Thanks for it.
Take one for yourself, Rob.
It's like a bag that goes in your bag.
Your Pixel book.
Yeah.
Your Pixel pad.
Was the Pixel book fit there? That'd be
I don't know. I don't think so. Be creative.
Good? Cool. Kubernetes, man.
Kubernetes. Get with it.
Oh, here you go. Done. Hey man, no worries. Thanks. Yeah, thanks for coming out. A lot of content, I understand. So that's what you have a whole nother month to do. Yeah, no, good. I know that quick labs are not like what I know a lot of people are like, oh, quick labs. I hope I supplemented with enough side feedback too. So thank you for coming out. Hope to see you next month too. Great job. Thank you so much. No worries. Yeah, no worries. Thank you for coming out. Yeah, thanks.
That was a lot of fun.
Yeah.
There's a few extras. This box is thrown. Yep.
Did you go? What do you think? I'm going to end the live stream. Thanks everyone on the live stream. If any questions come up, please, by all means, check out our future meetups. So thank you again if you're still on the live stream. Awesome work.
Thanks very much.
Hey man,
Really
thank you for
enjoyed it.
coming out. Thank you.